how do you run Python? There are many ways to actually run Python code. In this lecture, we will only focus on running Python code in Jupyter Notebook. To begin, we are going to install a Python with the free Anaconda distribution. It's free and open source, so you don't need to pay anything here. And as I mentioned, this distribution includes Python as well as many other useful libraries, including Jupyter Notebook environment, which is where we'll do our coding in this course. Anaconda can also be easily installed on major operating systems like Windows, Mac OS, and even Linux. After installing Python, we will proceed to run Python Notebook briefly, and finally explore other no-install options like Google Collaboration, which you do not need to pay anything or install anything. We are now going to download and install Anaconda distribution platform, which comes with Python 3.9. Anaconda is the most popular open source Python distribution platform in the world. Anaconda allows you to access open source software you need for your data related projects. It is user friendly and it's trusted. Anaconda includes many open source data science and machine learning tools like Jupyter Notebook, Spider, PowerShell, Jupyter Lab, IBM Watson, and so many other. To download, open your Google browser, as I've done, and type Anaconda distribution. You can search that and click on the first link that you see. Once it finishes loading, as you can see on the home page, we have a button for download, which comes with Python 3.9, a 64-bit graphical installer, and at the time of downloading this, it's 621 MB. You can go ahead and click on the download, and as you can see, it's currently downloading, and it's gonna take approximately 5 minutes, so you have to be very patient with this. It's still downloading. You're gonna give it time, and you're going to come back once the download is finished. It's about to finish installing, downloading, and as you can see, the downloading is finished. So what you do, you navigate to your downloads. You can open the downloads and right click on the and open. Once you open, it's gonna start installing process. So give it a bit of time to start. So as you can see, there's a welcome to Anaconda window that appears, and all you need to do here is click next. Read the license agreement. Once you finish reading, you click on I agree, and then it's recommended that you just choose just me if this is for personal use, but if it's in a work environment, it's recommended that you use all users, but for this one you require to have admin privileges. So in this case, make sure that you just click on just me and click on next, and now specify the destination folder where you want Anaconda 3 to be installed and click on next. And for the advanced options, just make sure that you check register Anaconda 3 as my Python 3.9, which should be the default one, and click on install. The installation process has started, and we'll come back once the installation process ends or completes. You can actually even click on details to see more details. We're gonna come back once that is complete. As you can see, the installation is complete. Setup is completed successfully. Next, you click on next. The next page shows some more information about Python and Jupyter in breeze. They say that working with Python and Jupyter is a breeze in data spell, but we don't need the data spell for now, so we click on next. And if you need Anaconda distribution tutorial, you can make sure that the checkbox is checked, as well as getting started with Anaconda, and click on finish. And just like that, we've installed Anaconda 3. It comes with Python 3.9. Well, now that we've been able to download Anaconda distribution for Python, we can go ahead and open it, or rather start it, and we're gonna see all the features that are there. So we go to Windows, search, and you can select, you can either type and search Anaconda Navigator, or you can simply select the recent, which is Anaconda Navigator here, and give it time for it to start. Yeah, it's initializing. As soon as it starts, it's gonna give you an option to update to the recent version of Anaconda Navigator. But now, for now, we say no, remind me later. As you can see, there are quite a few applications that are being hosted in Anaconda Navigator. You can see that there is a Jupyter Lab and Jupyter Notebook, which we're going to use for this course. And there's also another one that is very important when running Python, which is Spider, which is just a scientific Python development environment. And it's actually a very powerful IDE. And we can go ahead and launch Jupyter Notebook, which we're going to focus on in this course. And once you launch, it's going to open in your default browser, which happens to be, in my case, happens to be Google Chrome. And as you can see, the home page only shows the root directory, which shows you the folders in your root directory. The next step, we want to open a Jupyter Notebook. Once you click on New, you'll see there's an option to under Notebook, option to open a notebook using Python. Great. I can go ahead and click that as I do. And here we have now Jupyter Notebook. Has different sections. You can see that there's these options that you can click on. The file where you might choose to save the Jupyter Notebook, make a copy, rename, and other things. We have also edit, where this now helps you to make changes. Maybe you can copy or cut cell. And we have view, we have insert, cell, panel, widget, help, and the most important of all is this cell that you can see here. There are different things that you can do within this cell depending on which mode it is on. One, there's code. Code means that you can type code that you can execute. Um, Another option that you can, another mode is Markdown or heading. These ones normally allow you to input input text, textual, any text characters. Maybe you can write a normal text like you write in Word document, and you can actually even incorporate some formattings that can format the text in a way, the way you want, like having header. Maybe you can have a topic, a subtopic, and so on. So the only two options you have here is either you want to type text or the code. So in this case, we might decide to check if it's working. The best way to check if Jupyter Notebook is working is just doing a simple print. We can print hello world, print hello world, hello world. And to run this code, there are different ways. You can either click here on run. For this one, run will run the whole notebook. But if you want to run only this cell, you have to click on this one, the just on the left side of the cell, and click on it. Once you click on it, it will print the statement hello world. And another option how you can run a piece of code there, you can either click on control enter, it'll do just the same thing, just print out the hello world, or you can say just executes the current cell. The other option you can use is just hold on shift and hit enter. What that does, it will automatically execute the current cell and goes to the next, starts a new cell. If you do that, shift enter and start a new cell, which happens to be by default it's a code. You can do whichever calculations you want to do. Maybe you can say maybe a calculation 100 divided by 8. If you hit enter, it just goes to the next line. But if you want to execute, you just use the methods that I outlined earlier. You can use shift enter, which will show us the output and start a new cell. The other option would be changing this to Markdown,
and you can type any text here. You can say maybe Python is awesome. And if you execute this, it only shows, it's not text. You see, you realize the cell disappeared, but it just prints out Python is awesome, because the cell was actually Markdown, which was only accepting text. So once you do that, another cell appears. If you use Shift Enter, another cell appears. And if you want to edit this, the Markdown, you have to just double click and the cell will appear, and you can continue typing whatever you want to type. And basically, if you want to save the Jupyter Notebook, you can actually double click on Untitled too, because it's not saved. And once you do that, you can change the text, the notebook name. You can say maybe Python tutorial and rename. And you might want to save as. If you want to change the name, is save as. It'll give you the option, so you can just type the path relative to the notebook directory. You can so yeah. And here, if you want to know um, the working directory, you can type something like pwd, path to working directory, and that's my working directory. So the same thing would happen if you type that. And I think that's enough intro for Jupyter Notebook. The next option that you can explore is the no install. The no install, good example is Google Collaboratory uh, environment, where you don't have to install Python, you just have to go and run any piece of code that you want. You can do that. You come to Google and search Google Colab. Once you search, you'll find there are quite a few. If you click on welcome to this Google Colab.research, welcome to Collaboratory, you click on it. So once you search, it's gonna say welcome to Collaboratory, and you can insert a piece of code that you want. And once you click on code, uh, starts a new cell which only accepts a piece of code. Or you can click on text. It will only allow you to input text, just like Markdown in Jupyter Notebook. And we can insert a piece of code. I'll show you how to execute. Here you can do print hello world. If you want to execute, you can either hit Control Enter or Shift Enter, or you can click on this button here on the left side. If I click on the button, what does it will execute the code, and it's gonna print out the statement hello world. So as you can see, has printed hello world. You can choose to add text. If you can say Python is very powerful, and all you need to do is just execute just normally, Shift Enter, but all it does is just shows the text. So basically, you can type anything that you want to there. If you want to edit this, you just have to double click on it and you can continue editing. And that's it for the non-install. That's a good example where you don't have to install anything, and it's free. You don't have to pay anything. So it's a good option to explore. But in this case, even Jupyter Notebook is free, so you don't have to worry so much about the cost, unless you don't want to install other libraries that comes with Python. So for Google Collaboratory, you don't have to install anything. Everything is just there. It's already installed. You don't have to install anything. So, but in this case, we only focus with Jupyter Notebook for this entire course.
The first fundamental we will look at is the comments. To include a comment to describe part of the code, you must start the statement with a hash. A comment may appear at the start of a line or following a white space or a code, but not within a literal. All comments are ignored in Python. It is particularly important to add comments to describe variable definition or part of your program, because it is very easy to lose track of what you have done in your code, or for other people who would like to use your code. Another fundamental for Python, just like other programming languages, is that it uses variables. Variables are basically names that represent values stored in the computer memory. The values stored in a computer memory are able to change. The variables in Python are automatically created as soon as they are initialized. Normally, the variables are defined when they are assigned a value. When a variable represents a value stored in the memory, we normally say that the variable references the value. So, how do you create a variable? In Python, the assignment statement is actually an equal sign. For example, the variable num is assigned the value 20. In this case, the variable name num or the name num represents the variable, and the value 20 is stored in the memory location. So what this means is that the variable will be automatically created and it will reference the value 20. Let us try it out in Jupyter Notebook. If you have not installed Anaconda distribution, which comes with Jupyter Notebook, please watch my previous video. Now we can go ahead and start Anaconda distribution. We go to search, Windows search, and type Anaconda distribution and select under best match, click on it, and we can go ahead and launch Jupyter Notebook. We can go ahead and start a new Jupyter Notebook with Python 3. Once you click on it, this is the landing page. You rename this to Python Fundamentals, and then you click on rename. So the first thing that I'll do is convert this cell to Markdown, and I can go ahead and have the level 1 topic. All you need to do is just start with a hash sign, and now you can write whatever the topic is. And then the first thing we want to do is I'll show you how to add comments. For you to add comments, you have to start with hash. So in this code cell, make sure that now this is a code. We can add our comments. Remember we said that comment may appear at the start of a line. So we can add a comment. You have to start with a hash and you put a space, and then you can say something like that's, you can add a comment like that. That can be a comment. And also it can also appear after a code. You can say something like digits. Maybe we assign a value like 25, and then we can add another comment. This is another way of adding a comment. You can add hash, and then you can say also following a code. This here, this is a piece of code, and this is, we'll look at it later, but this is a variable and has been assigned a value 25. So this is another way of adding a comment. Also, we have another way. We can have a white space, and you can add a comment after white space. So you can say also following a white space. That's another way. So these three, all of them represents a comment in Python. In some instances, if a string character starts with a hash, it does not qualify to be a comment. For example, because the whole of this is a string. A string is just a data type where it's enclosed within these quotes. So this is not a comment. So what happens is that Python will automatically ignore any comment, but it will recognize this. This is now a code. This is another code where a variable of string type has been created in the memory. And this is just one way of having a comment. So they will be ignored. The next thing we want to do is create some variables. And now we can go ahead and initialize a variable. Remember, a variable will always be initialized using an assignment statement, which is equal sign, and then followed by the variable itself, the value. Now in this case, we can say that the value 20 is assigned to a variable named num. We can go ahead and print the value. You can say print num, and if you execute that, you can either click on this run button here on the left side of that code cell to execute, or you can you can hold the control key and hit enter. Num is a variable, which means that it can take different values. You can say, if you decide to change the value of num to 23,
and execute again, maybe control enter, the value of num becomes 23. That's why it's called a variable, because it takes usually take different values during the execution. There's also something else we call variable reference. Variable reference means that a variable is just the name given to the memory location. In this case, for example, here, the num is a variable name, and 23, where 23 is saved in the computer memory, that is what we call memory location. So the variable num usually point to the location where that is a certain memory location where a value of that variable can be stored. It can be 23, it can be 50. So it doesn't matter. We will now look at variable reference versus copy. Whenever the variable is used, it takes the value by referring to it in memory. It does not take value from a copy. For example, when num1 references the value 20 stored in the computer memory, and num2 references num1, num2 refers to the same object as num1, i.e., the two variable points to the same memory location where the value 20 is stored. In this case, Python uses referencing to memory. This is particularly important when working with large datasets, as you do not need to reserve computer memory for the same dataset. Going back to Jupyter Notebook, I'll show you how this is done. We might decide, for example, saying initialize num1 equal to maybe 20, and then we can also have another variable num2 that is assigned num1. So if you decide to print, for example, the value of num1, you realize that the value is 20. If you decide again now to print the value of num2, you realize that both of them are equal to 20. So something that you should realize is that num2 is using a variable rather than a value. So what happens here is that we don't create another variable. Remember that variable points to a certain memory location. But in this case, since num2 is referencing num1, it means that it doesn't take the value from a copy of num1. What it does, it takes the value stored in the computer memory that is being pointed by num1. So in this case, it's going to that memory location where there's a value 20 being saved, and now that's why it does return the value 20. So basically, we can see that num1 and num2 are both pointing to the same object. There is a clear difference between variables and constants. Variable is used to measure characteristic of interest that can take different values. The value stored in a computer memory can change during program execution. On the other hand, a constant is a quantity that has a fixed value. Once stored in a computer memory, constant does not change during program execution. A good example is pi, which takes on the value 3.14159. Let us go back to Jupyter Notebook to see this. Let us now look at how to initialize a variable and a constant. To differentiate the two, I'll use an example where we can get the area of a circle. We usually say it's pi multiplied by radius squared. The value of pi doesn't change. It usually remains the same, but the value of radius can change. You will have pi to be a fixed value, and we can have our radius r to be a variable. To define fixed value as a constant name, what we do, we usually use all uppercase. So in this case, to define it, we have fixed value. All these should be assigned a value 3.14159, and radius is our variable. So constant should be all uppercase, and for the radius should be all lowercase. So now we can decide what is the value of radius that you want to use. We can decide to use a radius 10. So we can say the area of circle is assigned constant value of pi and multiply it by the value of radius multiplied by radius. So we might as well decide to print area of that circle. If you run this, you actually get the value of 314.159. So that's how you are able to differentiate between a fixed value, constant, and a variable by the way you define them. So how do we name our variables in Python? Just like other programming languages, there are some rules to adhere to when naming variables in Python. Variable names must start with a letter or an underscore. Variable names cannot contain white spaces or punctuations. Variable names may contain letters, numbers 0 to 9, and underscores. Something else to note is that variable names are case sensitive and should never be Python keywords. There are several variable naming conventions, most of which are not mandatory, but very vital for readability of code and avoiding confusion. Variable names should be all lowercase, while constants should be in uppercase. Variable names should be short and descriptive. For variable names made up of multiple words, use either underscore to separate the words or use camel case to represent the two words. Whichever approach you choose, please be consistent. Class names should always start with an uppercase letter. A single leading underscore should be for private identifier and two leading underscore used for a strong private identifier. The next thing that we're going to look at here in Jupyter Notebook is how to name our variables. A good example is the name of a person. We can have a name and say something like Matthew. If you print name, it's going to print out name. That's a very good variable name. It's all lowercase and it starts with a letter. We can have it starting with underscore. Still, this will be recognized as a variable. But then let's try something else. Let's try it to start with a 1. Let's see what happens if you do this. Voila. It says syntax error, invalid syntax. The reason is because it can't start with a digit between 0 to 9. It can only start with a letter or underscore. The next thing I want to show is that we can have the same here. We can have letters and numbers or underscores. So you can have this one underscore, name underscore 1 underscore 1. This is valid variable name. But then let's try something else. What if we decide to have this to be our first name, and we have the space? Let's see what happens. If you try to have a white space in the variable name, what happens? You get invalid syntax. What this means is that you can never have a white space in the variable name. If you have multiple words that you want to use for your variable name, what you should do, you should either use an underscore between the two names, between the two words, or you can have something like maybe last name and say my last name. Let me just use my last name. And we can have something like this. So first name is Matthew, so we need to have an underscore. So rather than having an underscore, we can have camel case. The first letter is lowercase, but the first letter of the second word is capitalized. So these two are valid variable names. And something else you should know is that variable names are case sensitive. For instance, I initially defined first underscore name, which is all lowercase. Then you decide, look, let me just change this to try to call maybe first name with the F being uppercase. If you try to execute this, what does they tell you name, first name is not defined. The reason is because this is not recognized as small. So these are two different variables. These are two different approaches. Either use underscore or camel case. In your program, it's always recommended that don't mix the two approaches. The next thing I would like to say is that variable names can never be Python keywords.
all these words that are here can never be used for, you can never use these for your variable names, because there will be a conflict and that will cause problems for your program. So make sure that you never use these words. These are the keywords in it. And I think that's it for the naming conventions. But if you have any question, you can type in the comment section. Thank you for watching. See you in the next part of this Python programming tutorial. And please do remember to subscribe to this channel and turn on the notification bell. Hello, welcome again to this video tutorial on how to format Jupyter Notebook. Jupyter Notebook is a web-based interactive computing notebook environment. It allows you to edit and run human-readable docs while describing the data analysis. It enables you to represent textual information, code, and output in a visually appealing manner. It is very important to know how to format the notebook. The first important thing we are going to look at is the heading. To format the heading and titles, do the following. To have a title, the only thing you're supposed to do is start with a hash followed by the title name. That will give you the title. The next thing is having the heading. So we are going to have our heading in different heading levels. The first heading you use to hash signs followed by the heading name. If you want to have heading 2, you have hash appearing 3 times followed by the heading 2, and so on. If I execute this, that's what you get. The next thing we are going to look at is how to add emphasis on a piece of text. To add bold text, insert text in between a pair of double underscores. For example, we can add 2 underscores before text and double underscore after the text. If you execute this, you realize that the text in between the double underscores has been highlighted in bold. On the other hand, to write italic text, insert text in between a pair of single underscore. And for example, if you add the underscore before the text and an underscore after the text and execute that, you realize that the text in between the underscores has been highlighted in italic. The next important thing we are going to look at here is how to add line break in Jupyter Notebook. To add a line break, add BR, which stands for break, at the end of the line. For example, if I choose to write 3 sentences and I want them to appear in individual lines, then if I execute these, you realize that we get all the 3 sentences in a continuous single line. To ensure that all these appear in separate lines, you'll have to add a line break at the end of each sentence. So if now we try to execute this again, you get all the 3 sentences in individual lines. The next thing we are going to look at is how to add horizontal lines in Jupyter Notebook. On a new line, enter 3 asterisks. For example, if I want to add a line after the first sentence, I'm going to add 3 asterisks on a new line after the first sentence. So if I execute this, we get a horizontal line after the first sentence. The next thing we are going to look at is how to add colors in Jupyter Notebook. To highlight some text in different colors, do the following. You can use this special code to highlight your text in different colors. For example, all you need to do is specify the color in here and make sure that your text is here. If we execute this, we see that our text has been highlighted in different colors. The first text was highlighted in pink, the second one in red, the third one in blue, yellow, and green. The next thing we're going to look at is numbered lists and sublists. To add numbering to text, do the following. 1. For numbering, type a number followed by a dot and a space. For example, if I want to have 3 sentences and each is numbered from 1 to 3, what you should do is add the number followed by a dot and a space. If I execute this, you realize that we'll have a list that has been numbered. Again, we would like to have something like the sublists. Sublists is where we have
different form of numbering. To add those, we have to start with a tab space and then type a number followed by a dot and a space. And here we have a normal numbering. Then to add a sublist, you have to start with a tab space followed by a number followed by a dot and a space. And then you can have your text there. If you want to add a deeper subtext, all you need to do is have two tab spaces before the number followed by dot and then the space. So here, if I run this will look like this. The next important thing we'll do now is how to do text indentation. To display text in an indented block, start the line with this sign or arrow followed by a space and then the text. For example, if you just want to have a single indented block, you can have that symbol followed by a space and then the text. If you want a deeper indented text, you use two of those arrows. And if you want a more deeper indented text, then you use 3 and so on. If you execute this is what you get. The next thing we are going to look at is how to add monospace font. Monospace font is some text highlighted in a light gray background, and it's mostly used to highlight file paths, user entered messages, file names, etc. For example, to achieve this, we use a single quote on one side of the text and a single quote at the end of the text. And if I execute this is what I get. You can see that this text here, this is a monospace font, has been highlighted in a light gray background. Another very important thing that you should know how to achieve in a Jupyter Notebook is how to add mathematical symbols. To add mathematical symbols, insert the symbols in between the dollar sign. For example, if you want to add a function y is equals to mx plus c, which is a mathematical formula, what you do, you just add the dollar sign before the formula and a dollar sign after the formula. So if I execute this is what you get. And clearly, this looks like a legit mathematical formula, y is equals to mx plus c. The next thing we are going to look at is internal links. Adding internal links to jump to different sections of a notebook. Internal links has two components, the source and the destination. For the source, this has to be implemented in the location where you would like to get the clickable link. The format for this is as follows. It should look like this. This is where the text goes and the ID for that link. For the destination, this has to be implemented in the location where you would like to take the user once the user clicks on the link. The format followed for this is you start with a tag and then you have ID, then you close the tag. This can be followed by whatever content you want, be it text or image. For example, at the destination, you're supposed to have this. For example, if you'd like to have someone to click on a link to go all the way to the top of the page, you're supposed to define this in a cell on top of that page. And the source should have this. First, this is what the link will have, and this is the same as this ID, the name of that ID. For example, we can go ahead and define this. I'm going to copy, and then scroll all the way to the top of the page and then create that here. This is where now this is a destination. Once I paste that and hit execute, that disappears. You can't even notice that it's there. So going back to the link, now you create this link, the source. Once you execute this, you get this. This is the top of the page. That was the link name. But then there's a link to the top of the page where we defined this handle, the link handle, which is on top of the page. So if I click on the link, the source link,
it's gonna take me jump to the first page or on top of the page. So if I click it, let's see what happens if I click, it jumps to the top of the page. Now, this is very important because sometimes you might want to have content for your Jupyter notebook and you want to help someone. If they click on a certain link, we're gonna go to a specific section of that notebook. We can go ahead and look at external links. These links, once clicked, they should be able to take you outside the notebook. For example, if you would like to navigate to a personal YouTube channel, for example, here, this is my YouTube channel. What you do, you just define what you want displayed on the link, the clickable link. And then inside these brackets, you have to have your URL. Once I execute, you'll have a clickable link that once clicked is gonna take me to my YouTube channel. And going back to Jupyter Notebook, so we've been able to create external links to refer to a specific web page content in your Jupyter Notebook. We use a library called iframe. So basically, you are supposed to import iframe from ipython.display. What it does, it only helps you to display web content. Now this is where the code that you're able to embed your web page in. So you start with iframe and note that these I and F are capitalized, and this is where your link goes, the link to that web page. And then the display should be of width 800 and height 450. This it's all up to you. You can have it to be a small one or a bigger one, depending on what you prefer. If, for example, if I execute this, you'll get an output which will be a web page. Suppose now, instead of embedding a web page, we want to embed a PDF document. We will use the same library iframe and have the link to be the link to the PDF instead of the web page. And if I do execute this, I'll get the PDF instead. Moving on, you might want to embed a YouTube video in your notebook. And to achieve that, we'll use a library called YouTube videos from IPython display. And to do that, we use the function YouTube video. Note about the capitalization of this word. And here is where you have the YouTube video ID, and the width is 800 and the height is 500. We can go ahead and execute this to see what we get. So basically what happens here, we get a video, a clickable video that I can play. In some cases, you might want to add some graphics or just images to your Jupyter Notebook in a Markdown cell. So in this case, to achieve this, ensure that the image that you want to add to Jupyter Notebook is saved in the same working directory as your Jupyter Notebook. So to do this, we have to use this special code that will help you upload a picture, an image. In this case, you can see that it's called img src, and then we have the name of the image plus the extension, which is png image. I want the image to be displayed in these dimensions. Its width of 200 and should be left aligned. I have the image saved in my working directory. So once I execute this, the image will be embedded in my Jupyter Notebook in this particular cell. But because I want the image to be in a new line, I can simply add the line break here after the first sentence. So if I go ahead and execute this, the image will be loaded on this section after the first line here. So I can go ahead and execute that. So you see, we have our image which has been uploaded here and has been
left aligned. The next thing we are going to look at is how to change your Jupyter Notebook theme. By default, Jupyter Notebook uses a light theme. There are many themes that you can apply to your notebook, but you have to install them first. We can do it as follows. Launch command prompt from Anaconda distribution 2. If you do not have pip installed already, run the following command to install it. You can install pip by first running this command on the command prompt. Once you run this, it's gonna download a file called get.pip.py. Once you download this, I don't want to do it again because I already have pip on my computer. And once you download it, you're gonna run this. You paste it here and hit enter, and that will basically install pip on your computer. Then the next thing you do is install themes, which we're gonna achieve by running this command in the command prompt. Remember, the reasons why we were installing pip in earlier is because we needed to run this command, pip install Jupyter themes. Once you run this, you're not going to install the most recent themes. So you have to run this command to get the most recent ones or upgrade to these the most current Jupyter themes. And then to ensure that you have installed the themes correctly in your computer, then you have to run this command, this. And if I run this, it's going to show me all the available themes that I can change to. And then the next step is applying the theme of your choice to your notebook. And this is the code that you are supposed to use. But this has to be done on a code cell. If you want to change the theme to Chesterish, you just paste it here and run the cell. Once the cell has been executed, what you need to do, you have to close Jupyter Notebook completely for it to be implemented correctly. So I'm gonna make sure that you save first your work and close Jupyter Notebook. I'll close everything and relaunch Jupyter Notebook. Once I launch it again, this is what you get. And you're gonna open your Jupyter Notebook wherever it's saved. I've saved it under the name Formatting Jupyter Notebook. If I click on it, this is what I get. You see the formatting is now a bit different. To revert back to your default one, this is the code that you use. Exclamation JT hyphen R. This will revert back to the default theme. So all I need to do is run this code. Once I run it, it executes. But remember, for you to get back to your default one, if you make any change to the theme, you have to close and open Jupyter Notebook. So exactly what I'm gonna do, I'm gonna close it and just leave because I haven't made any change. I'm gonna close these two and I'm gonna launch it back. So this is how it looks like. And then I'm gonna go back down here and open my Jupyter Notebook by double clicking on it. And as you can see, I'm back to my default theme. And this is the key to remember when you're trying to change. You have to completely shut down and restart Jupyter Notebook every time you apply a new theme. And thank you for watching. See you in the next part of this Python programming tutorial. And please do remember to subscribe to this channel and turn on the notification bell. Welcome to this tutorial. We're going to look at the print method in Python. Basically, the print function in Python is a built-in function that allows you to output a string or any other data type to the console. There are several ways you can use the print function in Python, and the first one is print a string. You can have it as a heading, and to print a simple string, you can simply call the print function and pass the string as an argument. So for example, you can have print hello world. This is the string that you want to print out, and note that the string are enclosed in double quotes. So if I decide to print this, I get
hello world. The next way you can use the print function is print multiple strings. If you want to print multiple strings, you can pass them as separate arguments to the print function separated by commas. And so I can convert this to Markdown and convert this to heading. So for example, we can have separate words, separate string, and all you need to do is just pass them as arguments, separate arguments, but you separate them with commas. If I print this out, I get hello world. What Python will do here, to print the word hello and the word world and separate them with a space. So you get the two words or the two strings separated by a space. The next thing you can do is print some variables. Assuming that you have declared some variables and you want to print them out. For these ones, the only thing that you're supposed to do is just pass them as arguments to the print function, just like the way you're doing for the strings. For example, if you had a variable called name and the age of John in this case is 30, and then we wanted to print out a statement saying my name is John and my age is 30 years old. How to achieve that? You're supposed to come and print this out. Print, just pass the first argument to be a string, and then this will be a variable, comma, then you pass another string argument, and then age, which is the variable, and then the last part of the string. If I execute this, I get one complete statement saying my name is John and I am 30 years old. And that's basically how you can print the variables. And also, you might want to print string with variables. And how to do that? We can use some special string formatting to insert the values of the variables into the string. And we can have a small heading. So to do that, assuming we have the same variables, we have these two and copy and paste them there. And we wanted to print out a string and also these, the two variables. How to achieve that? We use the print function and format it this way. So you're supposed to use the percent sign s, and this will be the placeholder. So what happens is that the first variable will be substituted here and the second variable will be substituted here. So if I go ahead and print this out, I get my name is John and I am 30 years old. So that's how you can print out strings with variable by formatting the strings in this format. This will act as a placeholder where the variables will go. So basically, you can use this to incorporate variables into the string. The next way you can use the print is using something we call f strings. Add this as a markdown, so have it as a header. So suppose now we have our names, name and age variables, and we want to print these but using f string. And to print the same thing using this, we use a special format, and this special format is you start with f and then we write the first part of that string and then we enclose the variables inside curly braces. So basically where you want the variable to go, that's where we use the curly braces. And if I print this out, I get the same thing as what I got above, just the output above, which is the same as saying my name is John and I am 30 years old. And the next thing you can do is sometimes you might have some special characters that you want to print. You have string that you want to print out, but within the string, you have some special characters. And these special characters might be something like a new line, could be a new line, could be a tab, or some escape characters. You might want to print something with some quotes. So for example, to print a string with special character, you can use escape sequences. An escape sequence is a combination of characters that represent a special character. For example, to print a new line, you can use the backslash and then n. For example, assuming you wanted to print this, you want to print hello world and how are you today. You want to start a new line after hello world. How do you achieve that? Mark you, if for example I decide to do this and hit enter, then there's an error. So the best way to do this is to use forward slash n. This will print two lines because we have the escape character indicating that we are starting a new line. Also, to print with special characters, especially like multi-line, you might as well use triple quotes. But in this case, let me just do that. You can actually do this, hit enter. But instead of having a single quote, we can have three quotes. We have three quotes. So actually this will be able to print out two set of lines. So if I execute this, I get this, but then I have to remove that. So we need to have print and three quotes. That will print out multi-lines. Another thing that we might be able to print out with the print function is custom separators. Suppose you wanted to print out hello world, but in between the two words, you want to separate with something else other than the space. If you remember well here we printed out two separate strings into one, but separated them with the space. Now, in this case, if for example you wanted to print out a string, you wanted to print out string, but with custom separators. So to achieve this, what you do, you just come and pass the two strings as separate arguments in the print function and pass the third argument called sep equal, and then you enclose whatever the separator you want inside the bracket. So if I print this out, I get hello world, comma, hello, comma, world. That's what we get. And then there's also another way we can print without a new line. So suppose we have two pieces of text and you want to print them. It's like you have two lines. Just cut that. Then you have two lines, but then you don't want to, without a new line, print strings without a new line. So suppose you want to use two separate print functions, but then you want whatever will be printed out would appear in a single line. And to do that, all you need to do is come here and print hello, and then instead of ending the line so that you print out the next line, then you say end equal space. Now what this will do, the two will be printed as a single line. So you have hello world in a single line rather than having two lines. And I hope this is clear. If, for example, I try to do this as an example, I get two lines. But if you don't want them to appear in different lines, then what you do, you put a comma, then end equal space. Now this will simply substitute the new line with space. So I hope that is clear. Thank you for watching. See you in the next part of this Python programming tutorial. And please do remember to subscribe to this channel and turn on the notification bell. Welcome back. In this video tutorial, I'll go through the overview of the different data types we have in Python. Python has a number of built-in data types that allow you to store and manipulate different kind of data. The first one I'm going to look at is numbers. Numbers are classified into three. The first one is integers. Integers are basically whole numbers that can be positive, negative, or zero. You can use the int data type to represent the integers. A good example here, and a very clear one, is you can assign a value, a whole number 10, to a variable called x. A negative is assigned to a variable called y, and a 0, z. If you check the type of this data type by executing the cell, you get the int, which means the int is just a data type that is used to represent the integers. The next kind of number we're going to look at is the floats. Floats are basically numbers that have decimal points, and we use a data type called float to represent the floats. For example, we can have a positive float or we can have a negative float, but we can also have a 0, but it will be 0.0 something. So in this case, we can have an example where a value 10.5 has been assigned to a variable called x, and another negative 0.25 has been assigned to a variable called y, and z has also been assigned to a decimal number. If we execute the cell, we're going to see that the data type for the variable y is float. So that's the second number that we can have in Python. The last number is the complex numbers. The complex numbers are basically numbers with a real and imaginary part. In Python, you can use the complex data type to represent complex numbers. The real part is specified before j, and the imaginary part is specified after it. For example, so we have, this is the j is the imaginary part, and this, what comes before j, is the real part. And you can have these examples. X is equals to, or is assigned the value 3 plus 5j, which is an example of a complex number, which basically it's a complex because it doesn't take one, there's one part that's imaginary and the other part is real. So if you check the type, you get it's complex. The next data type you're going to look at is the string. And basically, strings are just a sequence of characters that can be used to represent text. And the data type that we use here is the str, to represent the strings. And we have two ways of defining the string type. We have single quotes enclosing the text, or a single quote. Both of them are of string type, but make sure that when you're defining, you cannot have a double quote and a single quote. Both of them have to be the same as if you decide to use single quote. You have to use single quote on both sides of the word. And the type is str, which is the string type. And you can also represent string in triple quotes if you want to define a multi-line string. For example, there are three lines, and you want to have them represented the way they are here. So you need to use three double quotes or three quotes. They can be single or double, depends what you want. And if you decide to print the type of x and also want to print the value x, so if you execute this, you get is of the string type is a string, and you have the three lines printed out. The next type of data type you're going to look at is the Boolean. For Boolean, these are just data types that allow you to define true or false. For example, you see that x has been assigned a value true and y has been assigned a value false. If you check the type of either x or y, you get is of the bool
So basically, bool is the data type used to represent Boolean. The next thing we are going to look at is the lists. As the name suggests, these are basically a collection of items that can be of different data types. So in Python, we use the data type called list to represent the lists. For example, we can have a list of integers, We can also have a list of string characters, or you can have a mixture of different data types. For example, you can have, this is an integer, this is a string character, and this is a float. So all this represents a list. If I decide to check the type of, maybe let's check y, if I execute this, it tells you that whatever y is of list data type. And the next thing you're going to look at is the tuples. And tuples are just similar to lists. The only difference is that it's immutable, meaning that you cannot modify or change the content once they are created. And in Python, we use tuple data type to represent the tuples. You can define a tuple using parentheses and separating the items with commas. For example, and you can have a tuple which contains a number of integers which are being separated by commas. You can have a tuple of a number of string characters separated by comma. Or you can have a mixture of different data types, which is maybe one is an integer, and apple is a string, and 3.14 it's is a float. And you can also check the type, and you can check, for example, z. Type of z it's tuple. So this is the data type. And the next thing we look at is the sets. Basically, sets are just an ordered collection of unique items. So they have to be unique. You cannot have different numbers. They have to be unique. They have to be unique, like 1, 2, 3. So, and how to define them? You have to use the curly braces to enclose your items, which have to be separated by commas. You can also have another set of string characters, some sort of number of strings that are being separated by comma. You can also have a set of Boolean characters or Boolean values or variables. And the last one we are going to look at is the dictionaries, which are basically an ordered collection of key value pairs. By key, they mean this. The first part is the key, and the second part is the value. And these pairs, you can have a number of pairs, and these pairs have to be separated by commas. And the value, the key and the value have to be separated by a full colon. You can have different value types or data types. These are basically integers. And the second one, the values are string characters, string character and integer, and another string character. You can also have another pair that has the value being float type, and they're enclosed in curly braces. So we use a type called dict. A dict type is used to represent the dictionaries. And if we decide to check the type, let's see what we have. We can check for x. If I execute this, I get a dict. So basically, that's an overview of how to define the different data types we have in Python. And in the next series of videos, I'm going to explain these data types individually, and it's gonna be very clear. I know at this point it might be very confusing, and these data types, there's a lot that you can do. So in the next videos, I'll explain to you exactly how to work with them in Python, and it's gonna be very interesting. And thank you for watching.
Please remember to subscribe to my YouTube channel and let me in the comment section what else you want to learn other than Python. You can tell me which part of data science you want to learn, be it machine learning, deep learning, anything that you would like to learn. Let me know. Thank you and see you in the next video. In this video tutorial, I will look at numeric data types. Numeric data types are used to represent numbers in a Python program. And in Python, there are several built-in data types for representing numbers. The first one we're going to look at is the int, which is basically used to represent integers and can store values from a big number, about 2 billion, about negative 2 billion to about positive 2 billion. If the number is larger than that, then we use the long data type to represent the integers that are too large to be stored in int. The long data type can be used to store any values of any size, but are generally slower to work with than int. The second numeric data type you're going to look at is float. And float is basically a data type that is used to represent floating point numbers. And floating point numbers are basically numbers with decimal points. And the next one that we're going to look at is the complex numbers. Complex numbers are basically numbers that have two parts. The first part is the real part, and the other one is imaginary part. And it's represented in a form. It's written as in a form of a plus b j, where a is the real part and b is the imaginary part. The next thing we're going to look at is how to work with numeric data types. And under that, we're going to see how you can declare these numeric data types. And basically, for you to declare the numeric data types, the only thing that you're supposed to do is just assign the numeric values to a variable. For example, if you assign a number 10 to a variable called x, then we say that x is an int, or basically an integer. If we assign 20 to y, y is still considered to be an integer or of int data type. If now we introduce a decimal point and assign that value to z, then we say that z is a float. And regardless of the number of decimal places that you use, still the variable will be considered to be a float. And now, if you have a complex number, which is 3 plus 4j, and assign it to a variable called c, then we say that c is complex, is of the data type complex. And there are some operations that you can perform using these numeric data types. And the first operator you can use is the plus sign, or the plus operator, if you want to add two numbers. You can use the minus operator if you want to subtract those numbers. You can use asterisk if you want to multiply the numbers, and you can use the slash or the division operator to divide the numbers. And this is very important to note. Two asterisks represents an exponent. You can do exponent of a number using the two asterisks, double asterisks. And then in case you want to get the remainder of a division, then we use the modulo operator or the percent operator. This is called modulo. So modulo operator can be used to calculate the remainder of a division. For example, we can find the total of x plus y. Basically, if you add two integers, because remember, x and y are both of integer type, which means the resulting sum will be of integer type. The same applies to if you decide to get the difference between two numbers, two integers, we get an integer. Likewise, if you decide to get the product of two integers, you still get an integer.
But if you decide to get the division of two numbers, then you get a float. Any division of two numbers, you get float. But if you decide to get exponent of a number and an integer, then you will get an integer. If you decide to get the modulo or the remainder of x divided by y, then the difference must be a whole number, which means that it's still gonna remain to be an integer. So we can execute this. Once you execute, we can check the resulting values. For example, we can check what the type of total will be. Remember that Python is case sensitive, so if you want to check the type, then this has to be capital T. But in this case, I'll correct this to be a small t for both, because according to variable conventions, variables should be represented in small case. You just use lowercase for everything. So you see that we get int for total. If we try to get the type for the difference, we get integer as well, int. We can check the division. For division, you get float. Remember, if you are dividing any two numbers, regardless if they are float or they are integers, you still get a float. And we can also check the value, the type of the exponent. We get int. And if we check for the remainder, we still get the same int. And you can also perform some operations on floats and complex numbers. And we're going to look at floats, how to do some operations with floats. Remember that we said that Z was declared as a float as well as W. So to get the sum of Z and W, we'll automatically get total to be float. Likewise, if you get the difference between Z and W, you get the difference to be float. Same applies to if you get the product of Z and W, you'll still get a float. If you do division, Z divided by W, you'll still get a float. We can actually run that and check and print out. We can check the value of the type of the product. If you execute this, you get is of the float type. That's for product. Same applies to diff. If I execute this, I still get float. The same applies to the division. You still get a float. And that's it for the floats. It's just straightforward. It's just like the normal math that you normally do using your calculator. The only difference is that these are variables are being created. Total is a variable that is being created, similar to difference, product, and division, and all of them are of data type float. The next thing we are going to look at is the complex numbers. We can still perform some calculations using complex numbers. And for complex numbers, you have to make sure that this is can get total, because it's a keyword. That's why it was sum was highlighted in green, meaning that it was a keyword. And if you use keywords for your variables, it's going to create some issues. So if you add C is a complex number and W is a float, if you add a float and a complex number, you automatically get a complex number. The same applies if you want to multiply a float and a complex number. You'll still get complex. And same applies if you decide to divide. You still get the same thing. And we can actually print maybe one outcome like total to see what we get. And if I execute this, you realize that you are going to get a complex number. And this complex number has two parts. Remember, this is the real part and 4 is the imaginary component. So there's so much you can do with complex numbers, but these are good examples showing that you can still do some calculations. But just remember that you have to check. If you check the type of, maybe let's take one example like total. If you print out the type, it's gonna be of a class called and the data type is complex. So, but you don't have to use the print. You can actually just do that. If I just want to print to check the type without anything else, we just have to execute type, and then in the parentheses you put in the variable name that is being created, and if you check, you get is a complex data type. And those are ways that you can do some operations using the numeric data types. But in some cases, there are some inbuilt functions that you can use to manipulate numeric data types. For example, you can get the absolute value, which is basically it's like you're multiplying, you're just removing the negative part. If it's positive, just remain positive. But if it's negative, then it's like you're multiplying it by -1 to get a positive. So if I execute this, the output would be 3.14. This now is a function. It's an inbuilt function called ABS, which stands for absolute value. And then also, you can round off some numbers. For example, this is quite a long number with how many decimal places? 1, 2, 3, 4, 5, 6. 6 decimal places. In some instances, we only want to round off to the nearest 2 decimal places, which means if I round off this to 2 decimal places, then I'm going to get 3.14. 3.14. And round is just a function that is used to do that. It has 2 components. The first component is the number that you want to round off, is a float that you want to round off. And this digit here just indicates the number of decimal places you want to round off to. And there's also another function called power. I can say power is assigned power of that. So this means it's like you want to get the exponent of, or just say 2 raised to 3. This is what the power function does. You just take 2 and raise it by 3. So is basically 2 cubed. And if we execute this, and there is some issue. Oh, sorry. Now you see, you have to ensure that you get the correct function name. The correct function name here is not power, but rather it's POW. That stands for power. And we can change this to be the variable name power, because this is not a keyword, but this is the keyword. So if I execute this, now you get it to run. If I can print out these values, can print out the absolute value. If I execute, I get 3.142. Is no longer negative but positive. If I check the value of the rounded, you get 3.14. If I print out the value of power, you'll automatically you'll have 8. You'll get 8 because 2 raised to 3 is 8. So it's actually working just fine. And I think those are the 2 examples of the inbuilt functions that you can use, but there are many out there that you can still use. And the last thing that we're going to look at is how to convert other data types to numeric, data types. For example, here we have 3.14, which is float. And if you execute this, if you check this is going to convert, it's going to convert 3.14 to integer. So basically, it's going to have it as 3. And suppose that you had a string type and is 3.14, but a string type. If you want to convert it to float, then you just have to execute, and you're going to get 3.14 because it's been converted to a float type. And you might have 3, 4. 3, 4. If you convert that to complex, then you're going to have 3. The first part, 3, will be the real part, and 4 will become the imaginary part. And we might as well print these values. If we print, you can actually print all of them together. A, B, C. Make sure that you just separate the whatever you want to print, separate them using a comma. If I execute this, I get 3, which means that 3.14 has been converted to int, and the string 3.14 has been converted to float, and 3, 4 has been converted to complex and became 3 plus 4j. And you can decide to check even the type. You can just insert a new cell and maybe check the type of A. Let's see what we get. We get int. You can check for B as well. You get a float, which is true. And we can check C. If we check C here, let's see what we get. We get complex. And it means that those values inside the brackets have been converted to numeric type. It's basically switching the numeric. So to convert to integer, you just use int, and then you put anything that you want to convert in the bracket. Float, you put whatever you want to have in the bracket. Complex, you have whatever you want in the same thing inside the brackets. And that's basically it for numeric data types. And next, we will look at strings. So be on the lookout for the next video. And thank you for watching and following. Hopefully everything is all right. If something is still not clear, please do post a comment on the comment section, and I'll be able to help you. Thank you for following, and see you in the next video.
String is a data type in Python that is used to represent text. A string is made up of sequence of characters. In Python, you can define a string using either single quote or double quotes. Triple quotes can also be used to define a multi-line string. We will now learn more about working with strings. To define a string in Python, we use either single or double quotes. For example, string 1 has been defined using single quote, and string 2 has been defined using double quotes. It is important to match the quotes when defining a string. If you use single quote to start the string, you must use single quote to close the string. If you use double quote to start the string, you must use double quotes to close the string. If you need to include a quote character within a string, you must use the other type of quote to define the string.
We can now go ahead and demonstrate how to define variables. And to define variables, you can either use single quote or double quotes. And so this is the first single quote, and you can as well use double quotes. If, for example, we decide to print this out, you can print the first one, string 1, and you can as well print string 2, just to confirm if both of them are the same. If I do print string 2, if I execute this, I get the same thing, which means that string 1 and string 2 are the same, despite being declared using different quotes.
To define a multi-line string in Python, we use triple quotes. This allows us to include line breaks in our string. Triple quotes can be used with either single or double quotes. It is important to use the same type of quotes to start and end the string. Multi-line are useful for defining strings that contain a lot of special characters such as new lines, tabs, and quotes without having to escape them. We will learn more about this next.
To declare a multi-string, then we can either use triple single quotes or we use triple double quotes. And if I execute this and print out string 3 and string 4, you realize that you're gonna get the same thing. Both of them have been printed out as two words, 2 lines each, which means this is another way you can declare variables. And it's particularly important if you want to use special characters like line break, tab, and you don't want to escape them. So that's where you can declare those.
In Python, we can access individual characters in a string using indexing. Indexing allows us to retrieve a specific character from a string based on its position in the string. In Python, indexing starts at 0, meaning that the first character in the string has an index 0, the second character has an index 1, and so on. For example, if you define a string 1 and assign it a string called hello world, then if we decide to print the first character, then we are going to say print bracket string 1, then you use the square bracket 0, and then you close the square bracket and then close the print brackets. The output will be h, which is the first character. If you want to print the second character, then you have to use 1 in the square bracket, which will give you the character e. We can also use negative indexing to start from the end of the string. In negative indexing, the character in the string has an index of -1. The second to last character has an index of -2, and so on. For example, if you wanted to print out the last character, which is D, then we have to say print strings, and inside the square brackets, we have -1. That will give you D. If you want to print the second to last character, then you have to use -2, and the output will be I. String indexing is a useful tool for accessing individual characters within a string.
To do string indexing, you first can have a comment string indexing, and you can also declare a string variable. Maybe say string 1. String 1 has a number of characters, and remember to count we start from 0, 1, 2, and so on. And you can also do the negative indexing. This one is position -1, followed by -2, -3, -4, and so on. So if you wanted to index, then we can use square brackets after the, for example, you can choose to print out the first character. You can say is string 1, use square brackets and specify the position, the index. And the index is basically the position of the character. So for example, if you want to print out the first one, then you print out square bracket 0. If I execute this, you get h. H is the first one, which takes up the index 0. If, for example, I wanted to print out the second character, I just change this to 1 and execute. You realize you get h and e, e standing for the second one. So we've been able to print out the second character. And also you can do negative indexing. And for negative indexing, you start counting from the end. And we can actually print out the last character. All you need to do is just copy and paste this and change this to -1, which stands for the last character in hello world, which should be D. We can confirm that. And suppose we want to print the second to last, you just copy this, you can have that, and change this to -2. If you print out this, you will get D and L. So this is the second to last, which means you're taking -2. And that's basically how you can index a string.
In Python, you can use slicing to access a range of characters within a string. To slice a string, use square brackets with the start and the end indices separated by colon. The start index is included, but the end index is not. For example, if you want to print the third, fourth, and fifth characters, set the start index to 2 and the end index to 5. The output will be LLO. If you want to print the first 5 characters, set the start index to blank and the end index to 5. The output will be hello. If you want to print the last 5 characters, set the start index to 6 and the end index to blank. The output will be world. You can also use negative indices to slice a string from the end. For example, if you want to print the last 5 characters, set the start index to -5 and the end index to blank. The output will be world. If you want to print the first 6 characters, set the start index to blank and the end index to -5. The output will be hello and the space. String slicing is a useful tool for extracting substrings from a large string. To do string slicing, then you can first declare a variable. We can call it a string. We can call it string, and we can go ahead and execute. And basically, to do some string slicing is that you want to select a piece of the string. For example, you might want to get the first three characters, or you might decide to get the last from 3, 4, and 5. You might decide to get the last 5. That's basically what we call string slicing. For example, if you choose to print out the third, fourth, and fifth character, and we can have 2:5. What this actually means is that this is included, the start index is included, but the last, the end index is not included. So which means is that since 2, given that we start from 0 to count, then 2 is the third character, the fourth character, and the fifth character. The sixth character is not included. I hope that is clear, because 5, index 5 is position 6. So if, for example, now we execute this, we get LLO. As you can see here, this is the third, fourth, and fifth. So this is 2 to 5, but 5, which is the space, is not included. That's why we're getting LLO. Similarly, if, for example, I choose to print out the first 5 characters, which means is character number 1, character number 2, character number 3, character number 4, and character number 5, we leave the start index to be blank, and we specify the end index to be 5. And if you execute this, you get hello. So those are the first 5 characters. And likewise, you can decide to print out the last 5 characters from character number 7 to the end. So you don't specify the end index, but you say 6. Remember, 6 now will be included. So if we count here, we have this 0, 1, 2, 3, 4, and 5. So we are starting from 6 all the way to the end. So if I execute that, we get the word world. So the last 5 characters. We might also want to do slicing using negative indices. For instance, we might want to print the last 5 characters, but now using negative indices. So we can do this. We can say, because we want to print the last 5 and -5 has to be included. Remember, we have -5 starting from, this will start from -1, -2, -3, -4, -5. So W is -5, and we want to print the whole word, including W
And since we know that the start index is included during slicing, then we just have to say it starts from -5 all the way to the end, because the end has been left blank. So if I execute this, you get the word world. Again, you might want, for example, to print out the first 6 characters and see. So basically, we want to print all the way to, this is position -5. We can have the same thing here, but and switch the places of, instead of having the start index, we can have it in the end index. If we execute this, let's see what we get. We get, if you can see, you notice that if I highlight it like that, there is a space. The reason for this is because, as you can see, we are indexing from the start. This means that it's basically from 0, at the start of the string, all the way to index number 6, but not including that index -5, which means is that it's gonna come all the way to the space. It's from 0 all the way to -5, but not including that -5. So you are going to get the word hello and a space. I hope that is clear for slicing. There are several inbuilt functions that you can use when working with strings. We can use examples to demonstrate that. You can go ahead and define a variable called string and execute that. If, for example, you just take string and put a dot and hit tab, you will see all these are functions that you can use to manipulate the string variable. So all I did was write the name of that variable, put a dot, and hit tab on your keyboard. You'll see all different sort of functions that you can use to manipulate the strings. We can use some examples to do a couple of them. For example, you might want to check the length of the string. You can use the len function. The len function will basically count the number of characters in that string, including the white spaces. So if I execute that, we see that the length of string is 19. We can also convert everything to lowercase by using the lower function, and we can go ahead and execute that. We see that it's lowercase string is hello world. We see that h has been converted to lowercase. The next thing we can have a look is converting everything to uppercase. So we just use upper, but you have to start with string dot upper, and you can print out the resulting string variable is just the hello world, where everything has been converted to uppercase. We can also check, we can also capitalize the string. By capitalizing the string, what it does, it just converts, usually converts anything that was in capital has been converted to lowercase. So that's how you're able to achieve that. Then the next thing we can do is count the number of occurrences of a certain substring. For example, you might want to count the number of times L is appearing in your string hello world, and we know that hello world will have, those are 2 and 3. Let's confirm if the count variable will do it for us. Let's count and see. Let's execute that. We get the number of occurrences of L is 3, which is true. You can also check if the string starts with a given prefix. So here we expect to have maybe a true or false. So for example, we might want to check if the string starts with space and h. To check that, we use the function called starts with, all small letters or lowercase. If you execute this, we see that starts with space and h is true. Because it's true, this is how it starts with that. There's a space and a h. Luckily for this one, if, for example, we chose to change this to small and see what it does. If you execute, you see it's false. The reason, remember our string starts with a capital H, which means that this is being lowercase, it's false. It doesn't start with a capital H. So we can revert back to our initial capital H and execute. So you find that that is true. Also, you might also be able to check if the string ends with a given suffix. And to do that, we use, so here we can use this, check if the string ends with a given suffix. We use the function called ends with exclamation and a space, some couple of spaces. So if I execute this, I print out the variable, which is the resulting variable. You find it true. You can also check something else, like if, for example, I say just copy the same thing and paste it there and say maybe just add one space. Let's see what happens. If we execute that, we see that it's false. The reason, we have an extra space. We have an extra space in our string, but in this we only checked if it ends with some specific characters, but had one space deleted. The next thing that we can check using the inbuilt functions, is find the index of the first occurrence of a substring. For example, you might want to check at what index does the first O appear. So now this is the code that you can use, the function that you can use, find O. This will return the first occurrence of the string O, or the character O in our string hello world. So if I execute that, you see that it's position 7. That is index 7. And we can as well go here and count. We just use the arrow keys in the keyboard to count. This will be 1, 2, 3, 4, 5, 6, 7. It's in position 8. It occurs in position 8. The index is 8. It occurs after 7. That's why we are getting the first index to be 7. The index of first occurrence, it occurs after index 7. It's index 8, but it occurs after 7. The next thing we can do is we can replace occurrences of a substring with a new string. And to do that, we are going to use the replace. It's just like find and replace. And to do this, we find the occurrence of O and replace it with a 0. And let's see what we get if we replace and print out the variable that is created. You see, we have our hello world, but in this case, O has been replaced with a 0. So that's how it looks like. The next thing we can do with the strings is split them. We can split them based on something. For example, we can say split the string into a list of substring, and to split them, we are going to separate them with a comma. Yes. So you are splitting the string into different words and separate them with a comma. And remember, we said if it's enclosed in square brackets, that's a list. So the split function will always create a string of substrings. So the next thing that we can do is join a list of strings into a single string. And to do that, we normally use the join function. And the join function will just take the words and join them together. Remember, we created a substring, a substring containing a list. So all we want to do is we just want to join them together and add a comma. So if I execute this, we see we are getting hello, comma, world. So you are taking this and this and joining them with a comma. Hope that is clear. And the last thing that we can do, we can remove leading and trailing white spaces from the string. For example, we know that our string has some spaces before and some spaces after. And to achieve that, we will use the function called strip. And what strip does, it just remove the trailing and the leading white space. That's all it does. If we go ahead and print this, we see that our white spaces have been removed. And there are so many other functions that you can use. If you remember well, I told you that you can just write the name of your string and put a dot and hit tab on your keyboard. You will see all of them. Thanks for watching this tutorial. I hope you found it helpful and learned a lot about strings in Python. Stay tuned for our next video. Don't forget to subscribe to my YouTube channel to be notified when the next video is released. Lists are a common data type in Python that allows you to store and manipulate a group of items in a specific order. Lists are mutable, meaning you can add or remove items from the list as needed. Lists have indices, which enables you to access items within the list by their position. Lists are iterable, which means you can loop through the items in a list using a for loop. In Python, you can create a list by enclosing a comma-separated list of items in a square brackets. Lists in Python are zero-indexed, which means that the first item in the list has an index of 0, the second item has an index of 1, and so on. To access an item in the list, you can use its index in square brackets. You can also use negative indices to access items from the end of the list. For example, the index -1 refers to the last item in the list, -2 refers to the second to last item, and so on. For example, if you wanted to create a list of items, then you say fruits is assigned a list enclosed in a square brackets, apple, banana, orange, and remember that all those are of string type, which means that they are enclosed in single quotes. And if you wanted to access the second item in the list, which that means that it's going to take the index 1. Remember, it's we start counting from 0. So which means that for you to access the second item or the second fruit, you say it's fruits, then in square brackets, you say 1. That will return the second fruit in that list, which is banana. And if you wanted to access the last item in the list, all you need to do is just assign fruits. Inside the square bracket, you say -1, and you assign that to a variable called last fruit. And the last fruit will contain orange, since that is the last fruit. I will now show you how to achieve this in Jupyter Notebook. To create a list, can add a comment, create a list. The first thing we do, will do the same example. Fruits, you assign it a number of fruits: apple, banana, and orange. And this is basically how you create a list. If you execute and print it out, say print fruits, you realize that you've created a variable of list type with 2 fruits inside. So something to note is that we use the square brackets and we add the list of items that you want to add and make sure that you separate them with commas. That's basically a list. The next thing I'll demonstrate here is how to access. Maybe you can access the second item in the list. And to do that, we use a square bracket with the index. So basically, let's find the second fruit. That's the variable name. And we want to get the second item. Remember, in Python, indexing starts from 0, which means the second item will have index 1. So we have 1 there. And we can go ahead and print that as well and see the outcome, print, and then fruit, second underscore fruit. And once you do that, if you execute that, you get you get an error. The reason is because our variable is fruits but not fruit, so you have to change that to fruits. If you execute that, you get banana, which means you've actually created a variable, and the variable is assigned the second fruit in that list. And then if suppose we want to access the last item, we can use negative indexing, access the last fruit or in the list. So to access that, you can say last, assign it to a variable called last fruit. And then what you do, we use negative indexing. So all you need to do is just say fruits, and then you have -1. Basically, if you are doing negative indexing, you start from -1, -2, all the way to negative, whichever the first element is. So basically, this will give us the last fruit in that list, and we can go ahead and print it, last underscore fruit. If you execute this, you get orange. And as you can see here, orange is the last fruit in that list. And that's basically it, how to create a list, access an item in a list, and this is basically the positive indexing. And we have negative indexing, where we use the negative indices to get the items from the list from the last or from the end.
Lists are mutable objects in Python, which means that you can modify their contents. To add an item to the end of the list, you can use the function append. To insert an item at a particular index in a list, you can use the insert method. To remove an item from the list, you can use the remove method. For example, to add an item to the end of the list, we say fruits equal to, and then you assign the list of the fruits, the 3 fruits, apple, banana, and orange. Now to append another fruit at the end, in this case mango, we say fruits dot append, and then inside the bracket you specify the word mango, which is a string character, a string of string data type. And if you wanted to insert an item at a particular index, in this case index 2, we say fruits dot insert, and then inside the bracket you say index 1 comma, and then you specify the name of that fruit that you want to add to the list, which is pear. So the new list has 4 items: apple, banana, has apple, and then pear, the one that has been inserted, and then banana and orange. So if you decide to remove an item from the list, and we say fruits dot remove, we want to remove banana from the list, then we have to enclose the banana inside the brackets, which means our new list, if you execute that, you're going to get apple, pear, and orange.
We can go ahead and do it in Jupyter Notebook. So the first thing we're going to do is add items in a list. We're going to use the same list we had created earlier. Fruits, which contains 3 fruits. So you can add a comment there. It's always important to add comments. We want to add items to the end of a list, and to do that we use append. So we say fruits dot append, and then what we do, we add the item that you want to add, which is mango, and we can go ahead and print the resulting fruits. We can say print fruits, and see, remember initially we had a list of 3 items. If you add mango at the end, then you should have mango, a list of 4 elements or items, and you see mango has been added at the end of that list. Then the next thing we are going to check is how to insert an item at a particular index in a list. Suppose now we wanted to add in this now, in our new list, if we want to add another item at the second position or index 1, then you can go ahead and do that. Add item, add an item at a particular index in a list. So to do that, we use the method insert. So all we need to do is start with the variable name, which is fruits, dot, and then you say insert, and then we have to specify two things here. The index, which is index 1, because we want to add in the second position, which is index 1, given that it starts from 0, then it means that the second position would be index 1, and then the name of the item that you want to include, which is, we can add pair, and we can go ahead and print this to see if our code works well. So fruits, you can use the print function, just say fruits. If you execute this, then you see that the second position, pear, a fruit called pear has been added, and the rest. So now, according to our indexing, the list has got how many elements? 1, 2, 3, 4, 5. 5 elements. The len function returns the number of items in a list. The sort method sorts the items in the list in ascending or descending order. By default, it sorts the items in ascending order. You can pass the reverse equal true argument to sort the items in descending order. The reverse method reverses the order of the items in a list. The copy method creates a shallow copy of list. This means that the new list is a separate object, but the items in the list are still references to the original object. For example, if you wanted to get the length of a list of fruits, 3 fruits in particular, apple, banana, and orange in that order. If you want to get now the length, you say num underscore fruits equal to len into bracket fruits. That will give you the number of items in that list. And if you wanted to sort a list in ascending order, all you need to do is say fruits dot sort. That will sort in ascending order, because sort will by default sort will sort the list in ascending order. If you wanted to reverse that order, you say fruits dot sort, and then inside the bracket you say reverse equal true. That will ensure that the list has been sorted in descending order. I can go ahead and demonstrate this in Python. And the first thing you are going to do is get the length of a list. And to do that, let's first declare our list, which contains apple, banana, and orange. And I'll first print this out just so that I show you how it looks like. Fruits. If you execute this, we see our list is apple, banana, and orange. So to get the length, you say length, maybe you can say num underscore fruits. You use the len function and pass the argument, which will take our variable, which is fruits, and we can go ahead and print it. Print num underscore fruits. If you execute this, you get 3. So that's basically the function that you use to get the length of a list. The next thing we can do is that we can actually sort a list in ascending order. So sort a list in ascending order. So to achieve this, you are supposed to use the function sort. So we take fruits dot then you use the function sort, and that's it. By default, that will return a list ordered in ascending order alphabetically. Then we can say, if you decide to print fruits, you realize that it will be sorted alphabetically. And if you run that, by default has been sorted alphabetically, although it was sorted even from the time we so nothing changed because the list was already sorted in alphabetic order. But if you decide, for example, to sort in descending order, sort a list in descending order, you use the same function. You can go ahead and copy these 2 lines, and inside the bracket, the sort function, you have to use the reverse argument and assign it to true. What this will do, it will reverse the default functionality of the sort method, which will ensure that the list has been sorted in reverse order. So the reverse of the default is descending. So if I do this, I execute this and hit Control Enter on the keyboard, you realize that the list has orange, banana, apple. And from this, you can see that the list has been reversed. So it's sorted in a descending order alphabetically. The next thing we can have a look is the reverse function. And the reverse function, all it does, it reverses the items. The last one will become first, and the second to last will become second, all the way to the last item. So we can say reverse the order of a list. And all we need to do is now reverse the list. Remember now our list of items is orange, banana, apple. So we want to reverse this from apple to print out apple, banana, orange. And to do this, we just take fruits dot the function reverse. And you don't have to pass any argument in the reverse function. So when you execute that and print out fruits, the list will become orange, banana, apple. If you continue running this cell, you realize that this will continue changing. For example, if I hit Control Enter again, the list keeps on changing. So basically, that's how you use the function reverse to reverse the order of a list. The next function we can look at is the copy function. And basically, this is used to create a copy of a list. And to do that, we just assign it to a variable called fruits underscore copy, and fruits dot copy. And we can have the function copy without any argument passed in there. So if I run this and print it out, let's see what we get. So if you print the word copy, so you're creating a variable that takes a copy of the variable or a list called fruits. So if I execute this, you find that you're getting the list called fruits and create another copy called fruits copy. And that's it for the copy. And that's basically the other operations that we can have a look at. These are the most common. There are others. If you remember well, I told you if you just type the name of that list and have a dot and hit tab, you'll see all the functions that are there for lists. You can go ahead and play around with them, how to use them, and you'll be good to go. But if you have any question, just post it in the comment section.
List comprehension is a concise way of creating a new list from an existing list in Python. To create a new list using list comprehension, you can use the following syntax: new underscore list equal to, and then inside square brackets, you specify the expression for items in the old list. You can also use an if clause to filter items in the list.
We can go ahead and have a look at this in Jupyter Notebook. And so can add a cell and have it you can have a comment called list comprehension, and we can use a few examples here. We can create a list that contains the square of each item in a number list. Suppose you have you can have another comment. You can have a comment there. We are creating a list that contains the square of each item in the list. And first, we can declare a variable called numbers. The list will contain the items 1, 2, 3, 4, 5. And to get the variable, another variable, which is the square of these numbers, basically we need to use list comprehension to get the square of this, which means it's just 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. So to do that, we use list comprehension. We open square brackets and say we want to get x raised to 2 for all x in the variable called numbers. So basically what this does, it will take all the variables, we say the elements are x. So what you're doing, you're taking x for all x. Maybe this is x1, x2, x3, x4, x5. So you're taking all those x1 to x5 and you get the square. Now that's clear. So this is how you write your statement here is x squared for x in numbers. And you can go ahead and print square. If you print out that, you get another list with 1, 4, 9, 16, 5, which means that all the numbers has been squared. Then the next thing, we can have another example. And in this example, we just want to select even numbers. And you can have a comment, create a list that contains only even numbers from the numbers list. And to get the numbers, what we do, we can say even equal and then square brackets. Then we say you are returning the values of x for all x in numbers if, now this is now a condition that you have to specify for x, if x is divisible by 2. And how to specify that, we say x modulo 2 and we assign it to 0, which means that if a number x is divided by 2, then the remainder is 0. That's one condition to check if a number is even number. If it was 1, then it means that we are looking at even numbers. So I can go ahead and print out this. So print even. What happens is that if I print that out, see, this is the live demonstration is crazy things. You see how I wrote my numbers. I can't even type, man. And I can say numbers, that's the actual variable name. So if I execute this again, I get 2 and 4, which is actually true because we know that our number list has only 2 even numbers. And that's basically it for list comprehension. You can actually do a lot with this list comprehension, and it's an easy way of creating a concise way of creating new lists from an existing list by using list comprehension based on a certain condition. Thank you for watching. See you in the next part of this Python programming tutorial, and please do remember to subscribe to this channel and turn on the notification bell. In this tutorial, we look at tuples in Python. Basically, a tuple is a type of data structure in Python that is similar to list but is immutable, meaning that its elements cannot be modified once it has been created. The first thing we look at is how to create a tuple. And to create a tuple, we have 2 methods. We can either use parentheses or we can use a tuple function. For example, we can use parentheses to create a tuple with 3 elements 1, 2, and 3, or we can create a tuple using the tuple function with 3 elements, but these 3 elements first were in a list, and that list was converted to tuple using the tuple function. We can go ahead and print T1, and we can as well print out T2. So if we decide to do that, execute this, and you can as well execute that. So you see we have two tuples. And the next thing we're going to do is accessing tuples in a tuple that we have created. There are two methods of accessing tuples. If you want to access a single element, then we use indexing. If you want to get a range of elements, then we use slicing. So, for example, we can decide to do this to access the first element of a tuple using indexing. Here, you create a tuple using parenthesis method, and we can print out the first element, which is this one. Remember, in Python, indexing starts from 0. So this will be index 0, index 1, and index 2. So to get this, to get the first element, then we use indexing method. So this one will return the first element. We can go ahead and print that out. And we can also use indexing if you want to access a range of elements in a tuple. And for example, you can do this. We can access a range of elements in a tuple using slicing. And for slicing, you specify the start index and the end index. So remember, since indexing starts from 0, this will be index 0, index 1. So the first element will be 2. And then the last element in this will be 3, which is in index 2, which means since we don't include the end index when slicing, then we are going to get the elements 2 and 3. And we can go and execute that. You get another tuple with elements 2 and 3. And that's basically how you access tuple elements. The next thing we look at is the tuple methods. The first method is if you want to count the number of occurrence of a value in a tuple, then we use the count method. So count method is one of two methods that we have in Python for tuples. So basically what this will do will count the occurrence of 3 in that tuple. A simple count returns at 3. We have 1, 2, and 3. So if we decide to execute this, we get 3, which is true. And the next method, inbuilt method that we have in Python for tuple is if you want to get the index of a number, of a value, then we use the index method. Basically, this will help you in finding the index of a value in a tuple. So in this case, we want to check the first occurrence of the value 3, which is index 0, 1, and 2. So this is index 2. So that's what we expect. We can go ahead and execute that. We get index 2. And basically that's all we have for the inbuilt functions that we can use for tuples. And actually I can even go ahead and show you that. We have our tuple to be t. If you type in a dot and hit tab in your keyboard, you see we have only two methods for tuples. I hope that is clear. So I'll go ahead and just delete that cell. The next thing we are going to look at is how to unpack tuple elements. And you can use tuple unpacking to assign elements of a tuple to separate variables. For example, suppose that you have a tuple with elements 1, 2, and 3. So if you wanted to assign those elements to a single, to individual variables, we use this assignment A, B, C equal to T. Basically what this will do, A will be assigned the value 1, B will be assigned the value 2, and C will be assigned the value 3. So suppose we wanted to print out to confirm if that happens. So that will be, we print out the value of the variable A. We can also print out the variable B, and we can also print out the variable C. If I execute this, you get the values 1, 2, and 3 in that order, because this will be the variable A, B, and C in that order. So basically meaning that the tuple has been unpacked to these separate variables. The next thing we are going to look at is a tuple comparison. Suppose we have several tuples that we want to compare. And suppose now, for example, you have 3 tuples. You have tuple 1, tuple 2, and tuple 3 with different elements. And you wanted to see if tuple 1 or tuple 2, or you can say tuple 1 is less than tuple 2. What we do, we use the common standard, or we use the standard comparison operators: less than, greater than, less than, or equal to, greater than, or less than, or equal to, or not equal to. So to see if tuple 1 is less than tuple 2, we can print that out. We use T1 is less than T2. What this will do, it will just return true or false. Let's see what happens. If I execute that, I get the value, the Boolean true. What that means is that these two elements, these two tuples have been compared element-wise, which means one, the first element will be compared to the first element of the second tuple. This will be compared to that, and this will be compared to that. If it happens that one of the elements when they're being compared is greater than, then that will be false. If it happens that all the elements except maybe this one is less than this value, then we return true. So normally what happens is that the first element will be compared to the first element of the second tuple, and if it's equal to, then we go to the next pair, 2 and 2, they are equal. If they are equal, then it's gonna go to the third one and compares. And since 3 is less than 4, then it's gonna return true. So that's how you do that. If you wanted to check if the elements are equal, if the tuples are equal, we can use that. Or you might also want to check if the tuples are not equal. Then if I decide to run this, you find that they're all true. I can change this a bit and say, suppose now we change this to maybe greater than, and execute the cell. You find that it's true, false, true, true, because this has been violated at this point. Because this is greater than this, then it's going to return false. And the next thing we are going to look at is tuple concatenation and repetition. And suppose we have 2 tuples and we wanted to concatenate the 2. Then what we do, we use a plus sign to do that. So to concatenate the 2, we say T3, we are creating a new tuple. T3 is assigned T1 plus T2. So if I execute that and print out, I see that T3 has the elements of T1 and elements of T2. Now we might also want to do some repetition. You want to repeat the tuple a number of times. So if you want to repeat that, then you can say T4, tuple 4 is assigned T1 repeated 3 times. So let's see what we get. We get tuple 1 repeated 3 times. I hope that is clear. The next thing we are going to look at is tuple membership. You can use the in and not in operators to check if the value is present in a tuple. For example, suppose that you have a tuple with 3 elements, and you want to check if a value 1 is present in that tuple. Then that will basically return either true or false. So in this case, checking that returns a true. Similarly, you might decide to check if a value 4 is in the tuple. So what happens is that Python will come and check if any of these values in that tuple is equal to 4. And if it's not contained in that, then it's going to return, let's see, it's going to return either false or yes. or false or true. And in this case, since 4 is not contained in that, then it's going to return false. And suppose we use not in in our statement. So suppose now we check if value 4 is not in our tuple T. Let's see what we get. We get true. What this means is that 4 is not in T. So we expect, since that is true, the statement is true, then we're going to have Python prints out true. The next thing we are going to look at is tuple iteration. In Python, we have different we call them loops that we can use to iterate over elements of a tuple. In this case, we can use a for loop. Suppose now we have a tuple T with elements 1, 2, and 3. And suppose now we want to iterate through all these lists, this tuple, these elements 1, 2, 3, which takes the index 0, 1, 2. So to do that, we use a for loop. So a for loop is simply written as for items in our tuple T. We want to print all the elements called items. So item. So basically what this will do, it will iterate over these values or the elements in that and print each individually. So if I execute this is what we get. So we have the values or the items in that tuple printed individually, and that's basically how you can iterate through a tuple. The next thing we do is we can look at tuple sorting. And for tuple sorting, we have to keep this in mind. Since tuples are immutable, it means that you cannot modify their elements. However, you can sort the elements of a tuple and create a new tuple with the sorted elements. You cannot change this exact. For example, suppose now we have a tuple with elements 3, 2, and 1. And you wanted to sort these elements in ascending order. So here you have to create a different tuple from these elements, and you make sure you use the function sorted. Sorted will basically sort that list in ascending order, and the tuple function will convert that list into a tuple. And maybe just to demonstrate how that is, I can unpack this. And suppose now I decide to print this sorted T. If I print out this, I get a list. So this will basically convert the tuple into a list. And now you assign that list, you have to convert that list back to tuple. That's why we're using the tuple function. We can go ahead and print out this, the new tuple. So if I print out this, I get the list that has been created by using the sorted function, and I get the list converted back to tuple. The next thing we are going to look at is tuple aliasing. When you assign a tuple to a new variable, a new tuple object is created, and the new variable points to the new object. Any changes made to the tuple through the new variable will not affect the original tuple. Note that in Python, tuple aliasing does not occur. We can demonstrate that. For example, suppose we had a variable tuple t1, and we have another variable t2, another tuple assigned to t1, and we want to check if t1 is equal to t2. So you can print t1, use the comparison operators equal, and t2. If I print this out, you see that it's true, simply because a tuple t1 was assigned to t2. So both of them are the same. And suppose now we make some changes to t2 by assigning it to a different tuple. If now I print out the same T1 to check if T1 and T2 are the same, then we end up getting, if I print this out, you find it's true and false, because any change to T2 does not affect the original tuple. And that's a clear evidence that tuple aliasing does not happen. And the next thing we are going to look at is tuple immutability. As mentioned earlier, tuples are immutable, which means that you cannot modify the elements once they have been created. This can be useful property when you need to store data that should not be changed. However, if you need to modify a tuple, you can create a new tuple with the modified elements. For example, suppose that you have a tuple T1 with the elements 1, 2, and 3, and you want to modify the tuple. How do you do it? So what you do, you just create a new tuple, and you want to change the first element, which takes index 1. So basically what you do, you just change the first element. So it's basically you're creating a tuple with 4, comma, don't put anything there, and then you add. You use plus, you use plus to concatenate it with now sliced, with a sliced tuple, or a tuple that has been sliced from the original one. So in this case, we can get T, and then we use the square brackets, and then we start from index 1 all the way to the end. So you don't have to specify the end index. So if I decide now to print our tuple T, this is what you get. You get, if we execute this, we get 4, 3, 4, 2, 3. And that's basically, you've changed this to 4 and sliced the original tuple to get 2 and 3 and concatenate them to the new, to this tuple which had the elements 4 only. So as we've seen that we have created a new tuple with the modified elements of the original tuple. I hope that is clear. The next thing we are going to look at is other operations that you can perform in Python. So there are quite a few. The first one we can look at is if you want to get the length of a tuple. If you want to get the length of a tuple, so basically the number of elements you have in the tuple, we can just simply print it out. So print length of a tuple. If you want to get the maximum or the minimum, we simply use this function. For minimum, we use min, and for maximum, we use max. Have it there. And if you want to get the sum of all elements in the tuple, then we use the sum function. So these are basically functions that you can use to get all this, and there are very many of them. So if I can execute that, we get this, which means we don't have our tuple, and we can simply create it in a different way. So before this, we can create a tuple by first defining the elements. So first you say x is assigned value 1, y is assigned 2, and z is assigned the value 3. And then now you can create a tuple variable with those variables. So if I create this, then and execute now, we get, these are the values, because you're getting the length. So the length of that tuple is 3. The minimum of x, y, z, of course, we get is x, which has the value 1. And to get the maximum, of course, it's z with value 3. So we return the value 3. And the sum is basically the sum of the 3 values is 1 plus 2 plus 3. And we get 6. So there are so many other things that you can do with tuples, but for now, I think you have all it takes to manipulate tuples in Python. Thank you for watching and for following. Hopefully everything is clear. But if something is not clear, please remember to post it on the comment section. Thank you for watching. See you in the next part of this Python programming tutorial. And please do remember to subscribe to this channel and turn on the notification bell. Welcome back. In this tutorial, we will look at Python dictionaries. Dictionaries are data structures in Python that store data in the form of key-value pairs. Dictionaries are useful for storing data that needs to be quickly accessed using a unique identifier known as a key. For example, let's say you have a list of students in a classroom and you want to store their names and ages. You can use dictionaries to store this information as follows. You can have a list of students in the classroom, and here, to store the information, the keys are the names of the students and the values are their ages, and the dictionary name is students, and the names of the students, Alice, Bob, Charlie, and David, are the keys, and the values are 20, 21, 22, and 23. If we decide to print out the dictionary students, we see we have the keys and the values separated by colon and are enclosed in curly braces, and that's one example of a dictionary. The first thing we are going to look at is how to create dictionaries. To create dictionary in Python, you can use curly braces to enclose comma-separated key values, and the keys and values are separated by colon. For example, you can have an example on how to create a dictionary using curly braces to enclose comma-separated list of key values. So in this case, we have the syntax my dict equal to curly braces, and the key values are separated with commas, and between key and the value there is a colon. And a good example is we may want to store stock prices for some stock, some various stocks, which are Apple, Microsoft, Amazon, and Google, and their corresponding prices. So this is how you do it. You just use the curly braces and define the key and values. And if I print this out, I get a dictionary. We can go ahead and check even the type of our dictionary, which is stock prices. If I execute that, I see that we have a dict, which is a dictionary. There's also another method that you can use to create a dictionary, and that is using the dict construct. So, and to do that, we use a syntax. We use a syntax called using the dict method, where the keys and the values are declared using the assignment operator equal sign. So key 1 is assigned the value 1, and key 2 is assigned value 2, and key 3 is assigned value 3. And that's the syntax. Going back to our example, if you want to use dict to create the dictionary called stock prices, then we just do this. We assign the stocks their corresponding prices and enclose them inside the dict method. So if I print this out, you'll notice that you get the same dictionary. Then the next thing we are going to look at is how to access values in the dictionary. To access the values in a dictionary, you can use keys as indexing. So to do that, this is the syntax we are going to use to access the values in a dictionary using the keys. So here, this is the key and is being used as an index. And here is our dictionary. So going back to our example, we can check the price of Apple stocks. And how to do that, we use the key Apple as our index. And if we execute that, it's going to get the price of Apple. So if I execute that, I get it's 100, which we can confirm is the same as the cost of Apple. You can also use get method to access the value in a dictionary. This method returns the value for specified key. And add a cell. So for this one, to use the get method, Then we use the syntax mydict.get, and then inside get we specify the key we want to get the value for. Going back to our example, we can get the price of apple using the get method. And to do that, we can have this where we specify the key apple inside the get method, and that if I execute this, I'll get the price of apple. And you can go ahead and execute that. We get the value 100, which is the same as what we got using the indexing method using the keys. And then the next thing we are going to look at is how to modify dictionaries. To add a new key value to a dictionary, you can simply assign a value to a new key. And to do that, and go ahead and add a cell. To do that, we use the following syntax, and is mydict, and inside the square brackets, we specify a new key that we want to add, and then we specify the value that we want to assign it. So going back to our example, we might as well decide to add a new stock and its corresponding stock price, and we can add a stock price, a new stock price for Tesla. And to do that, we just need to specify the new key and its corresponding price. If we execute this, we get our stock price. Our dictionary has now included a new key value, which is Tesla, and its corresponding value of 300. That's how to add. Suppose now we wanted to change the price of apple to 110. Remember it was 100. Now we want to change it to 110. So here is where we need to update the value for that existing key. You can simply assign a new value to that key, and we use this syntax and add that. That's the syntax we use to update a value for the existing key. It seems like it's almost similar to adding a new key, but if it doesn't exist, then you add it. But if it happens that it exists and you want to change the value, then you just include it. So the only thing that will happen is that the value will be added, will be updated. So going back to our example, we can update the stock price for apple. So, and this piece of code here will update the value of, or the price of apple to 110. We can go ahead and print out the stock price, and we see the value of apple has been changed from 100 to 110. Then we might also want to remove key value pair from a dictionary. To remove a key value pair from a dictionary, you can use the pop method. This method removes key value pair for the specified key and returns the value. So, and the syntax for that, we can simply assign mydict.pop with the key one specified to value. This will do two things. First, it's going to return a value, and it's going to remove the key one and its value from our dictionary. For example, we can go ahead and have it as an example for you to understand well. So here, we are removing the stock price for Amazon by using the pop. So what this will do is going to generate the value or the price of Amazon and print it out. So we can go ahead as well and print out our stock price to see what happens. Remember, this is our current stock price dictionary, and when I execute this, we'll see what happens. We'll see the price. So here we have two things. The price of Amazon, which was 200, and it's going to remove the key value for Amazon and its corresponding price from this from the dictionary, and you can see Amazon has been removed. Also, you can use delete keyword to remove a key value pair from a dictionary, and to do that we use the following syntax. So we use del my dict, and then we specify our key here. So we want to delete the key value for key 2 and its corresponding value, and that's your dictionary. So we're going to use an example to demonstrate that. And in this case, we are going to remove the stock price for Google. So in this case, all we need to do is use the key Google as the index, and we have the delete keyword here. And if I print this out, you realize that the Google and its corresponding stock price has been deleted. You can go ahead and print that out. And as you can see, we don't have the stock price for Google anymore because it has been deleted. And that's it for deleting key values. Then the next thing we are going to look at is the built-in dictionary methods. And these methods, we can have a look at them here. For example, we have our stock price as our dictionary. If you type a dot and you hit tab on your keyboard, you will see all the methods that are available for you to use when you are dealing with dictionaries. We have clear, which can be used to clear all the key values. We can create a copy of a dictionary. We can do from keys, get, items, pop items, set default, or update, or get the values. So in this case, we can go ahead and try out a few that are most common when you're dealing with dictionaries. And the first one that we are going to look at is the keys. And for keys, basically what keys method will do, it will just return a list of all keys in the dictionary. For example, in our case here, for the stock price, it would go ahead and return Apple, Microsoft, and Tesla. And again, we can use another method called value. For value, what value will do for you, it will simply return a list of all the values in the dictionary. We can use an example instead, or a syntax instead. So for the syntax, this is how the syntax will look like. My dict.values, that is the method values, which will automatically return list of all values in the dictionary. The next one we can have a look at is the items. In any dictionary, we have two main items, which are the keys and the values. In our case here, the method items will return a list of key value pairs in the dictionary. Then from there, we look at another thing called the len function. The len function, we've used it severally for other data types, is simply used to return the number of key value pairs in the dictionary. And to further understand this well, we can go ahead and use several examples. And to use the keys method, we can use it to return all the keys in the stock prices dictionary. And since we know that our keys are the names, we can assign the keys to names. If I execute that, you'll see that we have dicts keys, which includes key, Apple, Microsoft, and Tesla. So those are the keys. The next example, we can use the values. We can get all the values in our dictionary named stock prices. So if I execute this, I get the values 110, 50, and 300. And those are the corresponding prices for Apple, Microsoft, and Tesla. So the next example we can have to further demonstrate these methods, we can have the items method. And for items, we are going to get the key prices, the stock prices, the stocks, and their corresponding prices. They'll come in pairs. So if I execute this, you see we get dict items, Apple, comma, corresponding price, Microsoft and its corresponding price, and Tesla and its corresponding price. And something interesting here is that overall, that is a list of the key pairs. And the key pairs are an example of tuple, because you see tuples are enclosed in these parentheses, while lists are enclosed in the square brackets. The next example we can look at is the len method. For the len method, as mentioned earlier, is used to get the number of stocks in the dictionary. So in this case, you're going to get the length of the stock price. So if I execute this, I get 3, which is actually true, because after all the manipulations that we have done to our dictionary stock prices, we only have 3 stocks: Apple, Microsoft, and Tesla. And that's basically it for Python dictionaries. And as you've seen, dictionaries are a powerful and useful data structure for storing and organizing data in Python. With the knowledge you've gained from this tutorial, you should be able to use dictionary effectively in your Python code. But if you have any questions, do not hesitate to post them in the comment section and I will reply to them. Thank you. Thank you for watching. See you in the next video of this Python programming tutorial series. Please remember to subscribe, like, and turn on the notification bell. Welcome to this comprehensive tutorial on control structures in Python. Control structures are a fundamental part of any programming language, and they allow you to control the flow of your code. There are 3 main control structures. The first control structure we're going to look at is the if-else statements. They are used to execute a block of code based on whether a certain condition is met. The syntax is very simple. It has 2 parts, the if part and the else part. In the if part, that's where we specify the condition and we write the code that we would like to execute if the condition is true. We write it here. And if the condition is false, then we write our piece of code here that we would like to execute. We can do a few examples in Jupyter Notebook to demonstrate how to work with if-else statements. We can use 2 examples. The first example, suppose that you have a variable x and you wanted to check if the value of x is greater than 3, then we can do the following. That's our example. If suppose now you have the value of x to be 5 and you want to check if it's greater than 3, then we use the if statement. If x is greater than 3, then what do we want to do? We want to print out the value of x to be value of x is greater than 3. The condition will be checked. If it's true, this will be printed out. But if it's not true, then we print the else part. The else part will do the opposite of whatever happened here. Or you can specify a different piece of code. But in this case, we just want to check if it's true or not true. So we print out x is not greater than 3. If we execute this, then we see that x is greater than 3, which means this has been executed. The reason for that is that the condition was checked and it was ascertained that this is true. Given that it's true, this piece of code will be executed, and that's why we got x is greater than 3. Suppose now we had our value of x to be 2. Let's see what happens. If I execute this, I get x is not greater than 3. The reason for this is because the condition was checked and we have is 2 greater than 3. The answer is no, which means that this will return false, which means the second part will be executed and hence x is not greater than 3 was printed out. I hope that is clear. And there's also some instances where you'd like to check more than one condition. For example, suppose that you had a number or the variable x with a certain value, and you wanted to check if the value of that variable is greater than 10. If it so happened that it's not greater than 10, it's less than 10, then check another condition, which is check if it is greater than 3. So there are two layers. First, check if it's greater than 10. If true, then we are going to execute something. If it's not true, we check if it's greater than 3 and do something else. If those two conditions are not met, then automatically say it's not greater than 3. So the first thing we need is our variable x is assigned the value, let's say 6. So we want to check the first condition. So we say if x is greater than 10, then what do we want to do? We print out that the value of x is greater than 10. If that is not true, then we use the keyword elif, which stands for else if. Else if x is greater than 3, then what do? We print out that the value of x is greater than 3, but not greater than 10. What if now these two conditions are not met? Then we use the else component. The else component will mean that if these two have not been met, then it means that the value of x is less than 3, or we can simply say it's not greater than 3. So we print out x is not greater than 3. Let's now check what we get if we execute the cell. We see that x is greater than 3, but not greater than 10. Suppose now, instead of having 6 as the value of x, what if we had 2 and we execute? We get x is not greater than 3. The reason for that is that the else part has been executed. And what happened, what Python did is that it came here, replaced the value of x to be 2, and checked the condition. Is x greater than 10? Of course, it's false. So, because it's false, it goes to the next condition, check the next condition. So, it came to replace x here, checked if 2 is greater than 3. Is it true or false? It's false. So, has to go to the next block. The next block of which you have x. So, whatever happens, if that is not met, then we have to execute. This is the third part, of which now we return x is not greater than 3. So, suppose now, instead of 2, we had something like 14. And so what will happen here, in this case, before I even execute the cell, I'll come and check, is 14 greater than 10? Yes. So if it's true, then it prints out this. And it doesn't check any other condition, because the first instance where the condition was met, that's when it executed the code. So we can confirm that, and we see that x is greater than 10, which means the condition was met at the first instance at the if block. And that's it for if else. The second control structure we are going to look at is the for loop. It allows you to iterate over a sequence of items such as a list or a string. The syntax is as follows. We use the keyword for, then we write the item in sequence, and then we write a piece of code that you would like to execute on each item in that sequence. We can look at this in Jupyter Notebook. To demonstrate how to use for loops in Python, we can use several examples. And the first example I'm going to use is how to loop over a list. Suppose that we have our list called my list and has the numbers 1, 2, all the way to 4. And it's a list because it's enclosed in square brackets. Suppose now we wanted to loop over, or rather we wanted to print out 1, 2, 3, 4 in that list. Now, what we do, we use a for loop. And to use a for loop, we can say for items in my list, what do you want to do? You want to print the items in that list. So what this will do, I'll go to that list, and for the items can be anything. Can be anything inside that bracket. So for each item in that list, print that item. So if I execute this, you get 1, 2, 3, 4. So came here, took that item, which is 1, printed it out, then looped over to the next item and printed it out all the way to the last one. So that's one example how to loop over a list. you can also use loops, for loop to loop over a string. So suppose that's our comment. It's good to add some comments. Suppose we had a string called my string, and the string is maybe hello world, maybe exclamation. And now we wanted to loop over this piece of text or string. So here we use the same thing. You can say all the characters in that word are called char. Each is called char. You can call it anything. You can say it's X, I, whatever you want to call it. But in this case, I say for the characters in our string, what do you want to do to them? We want to print our individual character called char. So if you go ahead and print that out, we get hello world. So it'll print on individual lines. And that's another example. Suppose now, instead of string, we wanted to print out numbers, maybe between 1 and 100. There are several ways you can do that, but the best one you can do is loop over a range, a specific range. So this function here, range, it just says the range. If you put a number maybe like 5 here, what this will do is just in Python will understand what you mean. It's numbers from 0 to 5. So we can loop over that range from 0 to 5. And we can say for I representing the integers between 0 and 5. So we say I in, then we use the function range and say we want to print up to 5. Let's say something like that. And then we use colon at the end and then hit enter. And please note this indentation. If you just put here and hit enter, it will automatically create you proper indentation. So you have to hit enter while your cursor is immediately after the colon. If you click enter, you can now write the piece of code you want to write here. So you can say print, maybe we print our items which are i's. So it's I from 0 to 5. If I print this out, we get 0, 1, 2, all the way to 4. And the reason we are printing it's like we are printing from 0 to index. So we don't print out the fifth option. We are printing 5 elements, 5 items beginning from 0. So basically we printed out 0 to 4. There are 5 in numbers. So it's like we are printing out a range of 5 numbers. If we can change this to 10 and execute that, we get 0 to 9. So here you specify the number of numbers that you want to print out. If it's 100, it's going to print out 0 to 99 because Python starts counting from 0. That's why it's doing that. And then also we can loop over another data type like Python dictionaries. And that's a very good example, in fact, looping over a dictionary. Suppose now you had a dictionary called myDict and this is the key and the value. It has several key values pairs. And just a recap, for dictionary, the key and the value are separated with comma, and those pairs are separated by commas. So suppose now you wanted to loop over this and get the items in that dictionary. So what we do, we use a for loop, and in that for loop, we have to specify 2 things. So it's for, then we want to print out the key and value in that dictionary. So there's one function that's applicable for dictionaries called items function. And so here you want to call your function, which is myDict.items, and then you open and close the parentheses and no arguments in there. Don't add any argument inside the brackets, the parentheses, and hit enter. Make sure that your cursor was right after the colon so that when you hit enter, you get proper indentation. And what do you want to do? You want to print whatever you got here, the key and the value. And so we print key, comma, value. So we can go ahead and execute that. And what we get the key and the values printed out one at a time. So what it did, it came here, looked for items for key and values, key and value in the first instance, it just printed it out there. Then it looped to the second pair of key and value and printed out banana and 2 key and value basically all the way. Even if you had 100, that's the same loop. It's gonna loop to all the key value pairs. Hope that is clear. And we can also do something else with we can also loop for the values. For the dictionary, can also get the values alone. You have our dictionary. Suppose now you only wanted to get the values. You can do that. And instead of items here, you have values. And then here, you have value and execute. So you get the values 1, 2, 3, 4. Suppose you wanted maybe the keys alone. So if you wanted the keys, you change this to key and then these to keys. Those are just methods that you can use and then print out the key. If you print that out, you get banana, apple, banana, orange. So basically you just printed out the keys. You can basically do most things with the for loop. Yeah, so hopefully everything is clear. You can play with all these examples and make sure that you're typing them out, because that's the only way you can learn how to code well. So that's it for the for loop. The last control structure we are going to look at is the while loops. While loops allow you to execute a block of code repeatedly as long as a certain condition is met. The syntax is as follows. We write the keyword while, and then we specify the condition that you want to check. And here is where the piece of code that you want to execute while the condition you specified here is true. We can look at this in Jupyter Notebook. To demonstrate how to use while loops in Python, we're going to use an example. And suppose you wanted to print out the numbers from 0 to 9. To do this, you can of course use a for loop, but we want to use while loop. The first thing you do, you initialize the value of x to be 0, and then we want to print a number for as long as the value of x is less than 10. So that's the for loop condition, while loop condition, and we want to print the value of x. But then if I do this, we need to have a way of incrementing this from 0 to all the way to 9. So what we do, after printing the value of x, which at this point it's 0, the initial one, then we need to increment by 1. So we say is x, you add equal 1. So this was it's just doing this. You can just write here. It's just taking the value of x, assign it to x plus 1. This is what it does. So this has been this is the best way of writing it. So after doing that, if we execute this, we get the numbers from 0 all the way to 9. Remember our initial value was 0. So what the while loop did, it checked 0 against 10 and ascertained that the value of x is less than 10. Hence, it printed out the value of x to be 0. Then it looped again. After printing it out, it incremented the value of x by 1. So our current value of x is 1. So came here, checked the condition again. 1 is less than 10, true. It prints out the value of x and increment x by 1 all the way to 9. But at the point where it prints out 9, at the point where it prints out the value of x to be 9 and increments it by 1, so we have the current value to be 10, then what happens is that it checks, is 10 less than 10? It's false. So the while loop breaks, and that's it.
So at the end, it just prints out the values of x to be 0 to 9. But as we have seen, it's checking this condition. It's checking if the condition is true. If it happens that the condition is true, it will continue doing something. So for example, assume we had another, we decided to do this. You can have the same code, but instead of this one, assuming that we write this to be true. So if I try to print this out, let's see what happens. So what it does is start printing out the values. So it's infinite loop. It doesn't stop because the condition is always true. So what we do here in this case, we can interrupt the kernel by simply clicking on kernel and interrupt. That will basically stop the kernel, and the execution of that piece of infinite code will stop. So as you have seen, that it's very important to have an exit plan because something can go wrong. And to ensure that nothing goes wrong, we are supposed to use an if condition and say if x is greater than, maybe let's say 10 or 9, then what do? We break the code or the execution. And that's basically it for that. So once you insert the break, and if you decide to click execute, then you see that we are printing out 0 to 9. And that's another way you can use to print x, the value of x being 1 to 9. And if the condition is always true, then we need to have an exit plan by using the break command, which will stop the execution of that piece of code here. This is the piece of code that will execute for as long as this is true. And since we've already declared the condition to be true, then we need that break. And that's it for the while loop. And that concludes this tutorial on control structures in Python. If you have any question, please do remember to drop a comment, and I'll get back to you with the feedback. And please do remember to subscribe, like my videos, and leave comments. Welcome to this video tutorial on Python user-defined functions. Function is a block of code to perform a specific task. Python provides many built-in functions like print, len, etc. But you can also create your own functions. These functions are called user-defined functions. In Python, a function is defined using the def keyword, followed by the name of the function and a set of parentheses that may include parameters. The block of code inside the function is indented. Here is the basic syntax for defining a function in Python. You start with the def keyword, followed by function name. Then you open parentheses. You type your parameters. And after that, you close the parentheses, followed by colon. And once you hit enter, you make sure that you have an indented block called the function block, where you type in the statements that you would like to execute when you call the function that you've created. Below is an example of a simple function that takes a name as the parameter and prints out a greeting. Here, we have the keyword def and greet, which is the function name. And inside the parentheses, we have our parameter, which is the word name. The function will print the word hello and then name and exclamation mark. For example, if you try calling the function greet and you pass an argument called John, it's going to print out hello John. To return a value from a function, use the return statement. Below is an example of a function that takes two numbers as parameters and return their sum. We start with our usual def keyword followed by the function name. In this case, we call it add, which takes two parameters a and b, and the output we use the return keyword followed by what you want that function to do, which is add a plus b. If you want to call that function, then we assign the output of that function to a variable called result, and to call the function itself, we say add, which is the function name, and inside the parentheses, we pass the arguments.
and the arguments in this case is the number 3 and 4. So the expected results for that function would be 7. You can define a function with optional parameters by giving them default values. If a default value is provided for a parameter, the caller can choose to omit that argument. For example, we can define a function called greet, which takes the parameters name and greetings. But in this case, our greetings has been assigned a default value called hello. The function will print greetings, comma, name, and exclamation mark. So if, for example, we call the function greet and pass argument John, which is just the name, then it's going to print hello John. The reason is because it took the default greeting, which is hello, and the name of John that has been passed as argument and printed out hello John. On the other hand, if we print greet, we call the function greet and pass the argument John, which is the name, and pass another argument for greeting, then we'll print out hi John. The reason, the default value of greeting has been replaced with hi, and that's why it printed out hi John. We will now look at several examples involving Python user-defined functions. In this example, we will write a function that takes a list of numbers and returns the largest number in that list. The first thing we will do, we'll define a function if find largest, which takes the parameters numbers, and the first thing we'll do, we will set the initial largest number to be the first element in that list. So we can say largest is numbers index 0. And then we want to iterate through the rest of the numbers and check if any of those numbers is greater than our current largest number. So we use a for loop. We say for num in numbers. What do we want to do? If any of those numbers, or if num is larger than the current largest number, set it to be the new largest number. To do that, we use a if statement. So we say if num is greater than largest, what do? We assign that num to be the largest. So we say largest is now equal to num. And the loop will continue doing the same, checking one number at a time, comparing to the current largest number. And then once it finishes, it's going to return a certain value. So here is where we return the largest number after the for loop has ended. And here we use the keyword return keyword, and we return the largest number. So as you have seen, we've created a function called largest that takes in parameter called numbers, which is basically a list of numbers. And then we set the first number in that list to be the largest. And then now we check using a for loop if any of those numbers is greater than our current largest number. And if any of them is larger than our current number, then we assign that number to largest. We can go ahead and run this, make sure that we've done the correct thing. And then the next thing we want to do is we want to call the function. And how to call the function? We write the name of that function, which is find largest, and open parenthesis and close, and then we pass in a list. We can try 1, 2, 3 and see what will be the largest number. So if I run that, I get 3, which means that it's returning the maximum in that list. We can try another example. We call that function find largest. Once we find the largest, and then we pass in a list, we can say 10, 20, maybe 5, and then maybe 50. Let's see if it's going to return 50 as the largest number. Wow, we're getting the largest number to be 50. And suppose now we pass some negative values in there, what happens? So if we say find largest, and then we pass some negative values, -5, negative maybe 4, -60, and maybe 0. Let's see what we get in this case. So if I execute that, I get 0 to be the largest number. So our function is working well because it's just giving us the maximum in that list. Actually, we might be able to modify this using the functions that we already have in Python. For example, you can just copy and paste this here, insert a new cell. Instead of having all this, we can get rid of all this and just use a return. And then here, we can simply say return max of numbers. So if I execute this again and insert a cell and check, I can use the same example I used here. And if I call that function now, this, which is very short, what do we get? We get 50. So basically, this one is a longer version, but in programming, it's so much better to be lazy and just use a simple way of doing things. We just use 2 lines to declare that variable, which will give us the maximum in that list, as opposed to using all these lines. In this second example, we will write a function that takes a list of strings and returns a new list with all strings in uppercase. To begin, we define a function called to uppercase and takes the parameter strings, and the first thing we'll do is we will initialize an empty list that we are going to store the uppercase strings. So what we do is say upper strings, we assign it an empty list. Then the next thing we do, we'll iterate through the list of strings using a for loop. So we can say for s, let the strings in that string be called s in our list of strings. And for each s, what do you want to do? We want to convert them to uppercase. And after converting them to uppercase, we append them to the list that we created, the new list in this case. So to achieve that, you'll say our new list is called upper strings, and we want to append. We use the append function, and then for each string in that list of strings that we'll pass to the function, we convert them to uppercase. And to convert them to uppercase, we use the function upper. So that's why we are saying s.upper. Then after we convert them to uppercase and append them to the new list of strings, then we need to return the list of uppercase strings after the for loop has completed. That's why we need to make sure that we are outside that loop. And to make sure that you are outside the loop, we check the indentation. It should be in the same indentation as the for loop. And here is where we use our keyword return, so that you can return the upper string, which is the list of the new uppercase strings. And basically, just like that, we have created our function that will take list of strings and return a new list with all strings in uppercase. And we can go ahead and call the function. We execute this function that we've created, and we call it in the next cell. And we can use a simple example as ABC. So to call it, that's the name of our function. And then here is the list that we've passed as an argument. So we have that list in there, and we expect our function to convert it to uppercase. And let's see, moment of truth. Yes, has been converted to uppercase. All of them have been converted to uppercase. We can try another example that can convert towards hello and world to uppercase. So you have that. If you execute that, we find that everything has been converted to uppercase. And now we can also have another example, but for this example, I want us to make some sort of adjustment and write some numbers in between, maybe those strings. If I execute this, you realize that everything else has been converted to upper, but the numbers just remain the same. Thanks for watching and see you in the next video. Please also do remember to subscribe, share, and like my videos. Welcome to this tutorial on advanced control structures in Python. In addition to the basic control structures, Python has some advanced control structures that can be used to control the flow of execution of a program. The first one that you are going to look at is the try and except statements. The try and except statements in Python allows us to handle exceptions, which are errors that occur during the execution of our programs. Some of the exceptions may include, the first one is a zero division error, and this one will only occur if you try to divide a number by zero. You can go ahead and have an example. For example, if you wanted to declare a variable called x and the value is 1 divided by 0. If you try to execute that, you get an error. The error that you get is a zero division error. The next error we can have a look at is the type error. And this error occurs if you try to perform an operation on incompatible types. And for example, you might decide to create another variable called x, and you take a string, add 5. We know that that's not possible to add a string to an integer. So if you try to run that, we get type error and says can only concatenate string, not integer, to string. The next error we can have a look at is the name error, and this exception will only occur if you try to use a variable that has not been defined. For example, so far we have not declared a variable called y. So let's see if you try to print that variable called y. You get name error, which says name y is not defined. Another exception is called the index error, and we can have an example. Suppose we have a list maybe called my list, and it has maybe the elements 1, 2, 3. And as you can remember, we always start counting from index 0. So which means this is index 0, this is 1, and this is 2. Suppose now you wanted to get index 3. What happens? We don't have the index 3, but you want to call it anyway. So what you get is an error message, and the name of that error is index error, and says list index out of range, because you're trying to get index a list that only gets to index 2. So that's when you get that error. The next error you get here, you can get from Python program. It's the one called key error. This is associated to dictionaries, and for dictionaries, suppose you have a dictionary called mydict. It has a key called A and B, and they have the values 1 and 2 respectively. Suppose now you want to get some values for a certain key, and then suppose now you want to get the key, the value for a key called C. If you try to execute this, you get a key error because we do not have a key called C in that dictionary. And the next thing that you can, and the next exception that you can get is called the value error. And suppose you wanted to convert string to integer. Let's just try this and see. You get value error because you're trying to convert string to integer, which is not possible. That's why you get the error called value error, and it says invalid literal for integer with a base of 10. So 2 is not an integer and can never be converted to integer. So, and that's basically a few examples of exceptions. Now the biggest question is, how do you handle these exceptions? And to handle the exceptions, that's when try and except statements come in. So for example, if we wanted to handle specific exception that might occur in your program, we use the try block. Suppose you have that and you have 0, maybe something like you have a number that's being divided by 0. You're trying to declare a variable which takes the value of 1 divided by 0. So we know that we'll get division by 0 error. So what we do, we need to handle that exception, and we have to declare another block called except 0 division error, because we know we are going to get that error. And in that block, that's where you write the error message that you want to display. And in this case, we want to print out error message saying error division by 0 is not allowed. And so from these two blocks, the try and except block, we see that the try, that's where the code goes, the one that you feel like that can generate an error. And in the except, that's where we print out the error message. So we can try to execute this, see what we get. We get the error division by 0 is not allowed. In some instances, we might want to handle multiple exceptions. And to do that, there are two ways to do it. So the first way is by using the following piece of code. Here, in the try block, you might have two sets of code that might generate different exceptions. In our case here, we are trying to convert a string to integer, which means we are going to get an error, the value error, and also we are trying to divide by 0. So because we want to handle both of these errors, then we use in the except block, we use a tuple and include both errors in there and print out an error message saying errors, an exception has occurred. So for example, if I try to execute this, automatically I get error, an exception has occurred. The other way you can handle these exceptions, different exceptions, we can use two separate except blocks. And in our example here, we are trying to convert an integer is a string, but with a digit 5 or integer 5 enclosed in that string. So this one is possible. We can convert a string as long as it's a digit enclosed in the quotes. We can convert it to integer. So this one is not going to generate an error. So if I try to execute this, given that I have to accept blocks, one meant to handle the value error and another one supposed to handle division by 0 error, we are going to get, if I execute that, I get error division by 0 is not allowed, which means this error didn't occur. So we only handle the second part. Suppose now we had something like our original foo string. If I try to execute this, note what happens. I get the first error message, which means because we had two error message happening, two type of errors happening, only the first one was handled and the second one was not handled. So suppose we only had one error, which is the value error. Suppose we had this to be, let's say we had this to be 3, which means we are not going to return the division by 0 error and execute. We still get the first error. Suppose now we had this to be 5 and this to be 0. Let's see what happens. If I execute this, I get error division by 0 is not allowed, which means given that the first error didn't happen, this was ignored, but the second error was handled here in the second except block. So as you have realized, if you have both errors happening, only one error will be handled using this piece of code here. So to be sure that you're handling both, then we use this except block. We use the except block with both errors represented in the tuple, but you cannot have a specific error message for them. You only have a general error message. So if this happens, then you have to go back to your code and see which specific error happened. So, which means this can now handle both errors, but this is only able to handle one. And this is very important since suppose you wanted to have someone input some values. Maybe this was a value and this was a value that has to be input. And we are not sure at the point of designing the code if someone will actually type something that doesn't, something that might generate an error. That's why we can have these two. But this will not work if two errors occur. And as I mentioned earlier, we have different type of errors. So to handle any of them, we use this. We have to specify whatever you want to check in the except block. Now suppose none of the errors occur. It means that you want your code to do something. If there's no errors and you don't have to handle any errors, then it means that you need something to be done after that. And that's where we can add two kind of blocks. There's one block called else block that will go with try, except, and then you can add, after except block, we can add else block. And I'll explain that using an example. Suppose you wanted to convert an integer to a string to integer, and there's no error. Or for example, I can say, I can choose to write full. If I execute this, I get an error, which means that I have to handle. But what if now this was 5 and the string 5 was actually converted to integer, meaning that there's no error to handle? That means that you need to do something else, which is we are supposed to use else block. And what else does, you can specify a block of code that should be executed if none of the errors occur. So in this case, if I execute this, you'll see that the input value is valid, which means the else block was executed. I hope that is clear. Now, suppose that you wanted to specify a block of code that should always be executed regardless of whether an exception occurs or not. Here, we use the finally block. I'll use an example to demonstrate that, and we can use the following code. So what this piece of code will do, suppose you have an error that we expect to happen or to occur, and is a 0 division error, and it's being handled in this except block. And even if the error occurs or not, we still want to print out or to execute this piece of code. Finally will allow us to do that. For example, if I execute this, and note that there's an error that will occur. If I execute that, I get this printed out. Error division by 0 is not allowed, and this is also printed out. This code will always be executed regardless of whether an exception occurs or not. So that's in the situation where the error had occurred. But in the case where maybe assuming that the error didn't occur, we can change the 0 to 3, meaning that this operation is allowed. If I execute that, I only get the finally block being executed, which means it's prints out this error message, which is this code will always be executed. So as you have seen, a finally block will be executed regardless. And I hope that is clear. The finally block is useful for cleaning up resources or performing other tasks that should always be done regardless of whether an exception occurs or not. For example, you might use the finally block to close a file or a network connection that was opened in the try block. For example, assuming here you're opening a file saved in maybe a certain directory in your computer, and you expected that an error might occur. Maybe you wanted to open it and do some operations or write some materials, write something in the file, only to realize maybe there's an error. If an error happened, you still want to close that file. So that's where finally block comes in, because either way, whether the error occurred while trying to write the file, you still want to close it. So we use the finally block. Hopefully that is clear. The next thing we are going to look at is the break and continue statement, and have it as a heading. So the break and continue statements can be used to control the flow of a loop in your Python program. And the break statement is used to exit a loop prematurely, while the continue statement is used to skip the rest of the current iteration and move on to the next iteration. I can use an example. I can have a code here. I can add a cell. Suppose now you want to use break to exit the for loop. What this will do, the output for this would be, for this code, would be the numbers 0 to 4. Since the break statement will cause the loop to exit when the value of I is equal to 5. And we can actually execute that to see. So it prints out the value of I is equals to 1, 2, 3, 4, 0, 1, 2, 3, 4. But when it gets to 5, when the value of x is equals to 5, or the value of I is equals to 5, then it breaks the loop, and that's it. Another example of how to use continue, we can also use an example. And for this example, what you're trying to do is print out even numbers from 0 to 9. So what this code will do, it will print out even numbers 0 through 8, since the continue statement causes the loop to skip the rest of the iterations when I is odd. And if you can remember, this operation, this is the modulo, and what it does, it just checks if there's a remainder when a number is divided by 2. And as we know that odd numbers are not divisible by 2, and it means that they will always leave a remainder of 1. So this condition is just checking if the number is odd or not. So if it happens that the number is odd, then continue will skip to the next iteration. Now when the value of I becomes even, meaning that this will be violated, then the value of I will be printed out. So that's it for the break and continue. The next thing we are going to look at is the pass statement. For pass statement is just used as a placeholder when a statement is required but no action needs to be taken. For example, you might use a pass statement as a placeholder in a loop that has not yet been implemented. For example, suppose you wanted to do something with a range from 0 to 9. The reasons why I'm saying 0 to 9 is that this is 0 to 10, but in that range, this is not included. 10 is not included, meaning that since it starts from 0 for 10 items, the numbers that we want is 10, but starts from 0, so it's 0 to 9. And you just write this pass will act as just a placeholder for a future code. You can now decide to come and write something like this, a piece of code here. So this is just acting as a placeholder. This will be executed, but there's some sort of operation that is required, but no action is required at this moment. So this can be left there to act as a placeholder. And so you can say being used as a placeholder in a for loop. Also, this can also be used in a try except block. For example, you might have something like this: a try where a number is being divided by 0. We expect an error, but at this point, when you are writing this piece of code, we are not sure what you want to add here. So you want it to occur, but you're not sure what you want to have at the moment. You know there is an error, but you're not sure what you want the code to do. So you just leave the keyword pass to act as a placeholder for future exception handling code. So I hope that is clear for pass. So basically, we say that the pass statement is often used as a placeholder when developing code and is later replaced with actual code as needed. And that's it for this tutorial on advanced control structures. Just a recap, in this tutorial, we covered some advanced control structures in Python, including try and except statement for handling exceptions, break and continue statement for controlling the flow of a loop, and the pass statement, which act as a placeholder. These control structures, as you've seen, can be very useful in Python programming and can help you write more robust and efficient code. And what I would urge you to do is please try and practice using these control structures in your Python programs to get a better understanding of how they work, and that will be super helpful for you. Anyway, thank you for watching, and please do remember to subscribe, comment, and like my videos.